warm and delightful morning, everyone. I am Raksha Tripathi, and it is indeed my honor and privilege to welcome you all to day two of the International Conference on Recent Developments in Science and Technology for Achieving Sustainable Goals Using Statistical Techniques, organized by the Amity School of Applied Sciences, Amity University, Uttar Pradesh, Lucknow campus. On behalf of the organizing committee, I extend my heartfelt welcome to our esteemed dignitaries, researchers, and participants who have joined us both offline and online. Your presence truly enriches the value of this conference. It gives me immense pleasure to welcome the esteemed dignitary presiding over this session, the session chair, Dr. K.K. Singh, sir. Sir is an associate professor in the Department of Electronics and Communication Engineering at Amity University, Lucknow campus. With 22 years of teaching experience at B.Tech level and 20 years at M.Tech level, he has guided and inspired countless students. Sir has published 75 plus research papers in international journals and presented 125 plus papers in international and national conferences, seminars, and workshops. We are grateful to you, sir, for your time, expertise, and contribution in shaping today's session on machine learning algorithms and applications. Through these thought provoking sessions, we are truly training our minds to think beyond boundaries and embrace sustainable progress. Now, to commence today's deliberations, it is my privilege to invite Professor Dr. Masood Hussain Siddiqui, sir, professor at the Department of Statistics, University of Lucknow. Sir is a distinguished academic in decision sciences and business analytics with extensive experience in education management. He began his teaching career at Lucknow Christian College and later served at Jaipur Institute of Management before joining the University of Lucknow. His expertise spans data sciences, data analysis, market research, optimization, statistics, and business development. With 40 plus research papers published in reputed international journals, he has also conducted 150 plus FDPs and MDPs across universities, management institutes, both private and public sector organizations. Now, with great honor, I invite Professor Dr. Masood Hussain Siddiqui, sir, to deliver his presentation.
मुझे लैपटॉप चेंज करना पड़ेगा इसका माउस सब प्रेजेंटेशन न्यू आप बताइए मैं वहाँ पे चेंज कर देता स्लाइड चेंजेस तो मैं अपना लैपटॉप पे तो बस एक मिनट लैपटॉप चेंज कर So like here.
Hello, hello, check. Hello, hello.
लेकिन इससे हमको उस पर ला के करना पड़ेगा ना, यूज डायरेक्ट नहीं हो पाएगा ना। हाइट वाला तो should I start? Okay. नहीं विंडोज की कर रहा हूँ ये तो हो गया। एक्सपेंसिव कैसे हो जाते हैं? क्या सेटिंग यहाँ का तो लगा ही प्रॉक्सी फोटोग्राफ। थैंक यू। अपना फंडिंग इसको देखते हैं morning, participants to the conference, and thanks to MIT School of Applied Sciences for inviting me to this conference for this session. This session, since this session is actually related to machine learning, and my paper or the presentation is also related to that only. As we know that in the machine learning, there are two algorithms, two models are actually there, basic models. One is supervised learning, other is unsupervised learning. In the supervised learning, again, we have two broad algorithms or the models. One is supervised learning regression, other one is supervised learning classification. So this is actually related to supervised learning classification. In the classification, as we know, if you have some idea about the classification, the Y variable or the target variable is related to the different categories. Suppose we are examining the model related to fraud detection. So in the fraud detection, there are two categories in the Y variable, that is fraud will be there or fraud won't be there. Means that activity is fraudulent, and the next one is that activity is not fraudulent. In the same way, if we go with the medical sciences, suppose we want to examine that whether the person is having cardiovascular disease or a particular disease like cancer. So again, there are two categories. One is person is having cardiovascular disease or the person is having cancer. And that other one is person is not having cardiovascular disease, or in some other case, person is not having cancer. So these are known as classes or the class labels. So whenever these algorithms have been designed related to classification, the efficiency of the algorithm is based upon the fact that there is approximate equal representation of both the categories. But it is not normally the case is like if we examine 1,000 or 10,000 financial transaction, so the fraudulent activity will be in only a few of those cases. In the same way, if we examine a large number of patients, right, obviously the person is having cancer won't be that much high. So in that way, we have unbalanced data set. Unbalanced data set means there is not equal representation of the categories of the dependent variable. So there is always a challenge of the unbalanced data set. Moreover, in all these real life problems, like the problems that we have discussed here, normally we have a number of features are required so to define the Y variable. So that is known as high dimensional data. Means number of features, number of independent variables are very high, right? So primarily these two problems are being studied separately, but in the last few years, a lot of concentration is on the amalgamation of these two problems. Like the data set is high dimensional data set as well as the data set is imbalanced in nature. So this is a review paper where the different algorithm or the different works that has been considered on this topic. And it is with my research scholar, Rajat Raj, right? So this is the paper or the review paper that we are going to discuss. As we know that, I have already mentioned that there are two challenges that affect the model performance, right? Model performance means the accuracy or the different measures that are required to examine whether the model is good or not. There are impact of these two factors. One is class imbalance that I have mentioned. The other one is our data is having high dimensionality or number of features are too large, right? So what happens if the class is imbalanced, then number of matrices that are being used to examine the performance, like recall, precision, even if you go with the accuracy, there is an impact on these. Even F1 score is not that much good to cover the cases when our problem is imbalanced in nature. So this was widely studied by a number of authors. So two authors I have mentioned here. The second one is our data set is having high dimensions, number of features are too large. So because of high dimensionality, data become sparse, and because of that, we will be facing the problem of overfitting, right? So these two problems are there. And again, the second problem is also being discussed by number of authors. But actually, the main problem is start when these two problems occur simultaneously. That is the compounded problem. So in that case, we have different methodologies to handle class imbalance. Like we go for random oversampling, random undersampling. We also have a very popular algorithm that is known as systematic minority oversampling technique, that is known as SMORE, right? But these problems, these solutions are related to those cases where only the class imbalance is there. High dimensionality is not the issue. In the same way, if the problem is having only one issue, that is high dimensionality, then we use a number of dimensionality reduction techniques like principal component analysis, factor analysis, linear discriminant analysis, and so on. But these problems are also uh, becomes a critical if our data set is imbalanced in nature. So if these two problems occur separately, then there won't be issues with the methodologies that has been suggested. But in case there is a combined problem, so there is always an issue. So for that purpose, different authors have concentrated mixing of these two that are known as hybrid method. So it integrate the resampling strategies like that has been mentioned, like SMORE, for example, with feature selection or the dimensionality reduction technique. And it was observed that the hybrid approach where the two techniques are being mixed, it has a better performance as compared to using the standalone technique that has been used separately, right? So, and this problem is very pertinent, very important when we have domains with high stake and complex data distribution, like we have genomics, bioinformatics, image-based diagnostic. We also have financial frauds also. So in these cases, this problem become a big one. And since hybrid methods has been suggested to it impact both on predictive performance on the different matrices, evaluation matrices, we normally get better results. It also provides the model interpretability. It is easier to define how to interpret the model, as well as the model become reliable and transparent. So this paper actually present a comprehensive review of the different hybrid strategies addressing class imbalance in the high dimensional data. And our focus is on the algorithms, right? Next, how these models are being defined, that is the architectural innovation and the evaluation matrices. Since in SLC, we have a number of evaluation matrices. So and there is no technique that is good on all the evaluation matrices. So our focus is on these three issues. So a range of algorithms are critically examined in terms of how they are being examined, what is the principle, how efficient they are with respect to computation, because we always say that machines shouldn't take too much time to analyze the data. Since the data set are too big, so we have to put minimum burden on the machine. So that is the computational efficiency, as well as how effective they are empirically. And it has been observed that there is a trend on this algorithm. So special attention is given to the trend that goes up to the future trend, where we mix the hybrid algorithm as well as the cost sensitive issues are there. So we divided our work into three categories. The first one is where some traditional approaches, traditional models are being used as an hybrid model. After that, we have used feature selection along with the ensemble learning, like ADA Boost, Random Forest, and so on. And after that, the current trend that is related to deep learning and the different evaluationary algorithms are there. So first we discuss the work that has been done on the traditional hybrid models. So like it was started in 2002 when Chawla et al. Have mixed SMOT as well as principal component analysis or linear discriminant analysis before or during resampling. Right. So these two techniques are being used separately. Now they are being mixed. After that, Hang et al. In 2019 has done a very different work where they combine principal component analysis for the dimensionality reduction, as well as they have used topological sampling. Uh, if you have some idea about the sampling, normally we go with the random sampling. But the topological sampling is that type of sampling where we use the same distribution like the distribution of the minority classes. So what is the approach is being used? If some class or some category is underrepresented, we create some minority examples or minority instances for that. So here topological sampling is useful because it uses the same probability distribution. So it combines PCA with topological sampling to enhance the synthetic data generation process. Right. So this process along with SPOT has been used. After that, Mullah et al. In 2021 studied the impact of PCA separately, SMOT separately, and after that they combined PC and SMOT on the classification performance. And they have again used a data set that is highly imbalanced and high dimensional data set is there. And they have examined that mixing of this technology gives the better results. After that, Wang and Yu in 2020 use hybrid clustering, SMOT, and classifier a chain so to encounter these two problems. And the results are quite good. The same thing has been continued by Zhang and Wang, where they have mixed SMOT, that is a minority oversampling minority undersampling technique with feature weight clustering. So they mix SMOT with clustering. After that, Kumar et al. In 2021 have used hybrid PCA, WOA, and SVM, where they have integrated principal component analysis with whale optimization algorithm that covers the overall, like how the whale catches a fish, right? So that is the algorithm that is being used so to optimize the performance. And they have also mixed the feature selection along with the support vector machine, right? So in this manner, they have introduced a hybrid model. After that, Rahman et al. Have used particle swarm optimization, another type of optimization, along with SMOT and chi-squared feature selection, so to encounter these results. Then the next paper is by Bera and Ray, that has employed improved gray wolf optimization. So to improve the performance, along with the feature selection. Feature selection, when we have high dimensional data, then we select certain features that are supposed to be important one. And they have coupled with SMOT. SMOT is synthetic minority oversampling technique. So these are the works that basically use the traditional algorithm, and they have propagated, they have processed the different hybrid models. After that, the second category, the simultaneously the work is being done on feature selection that is being used so to um, reduce the dimensionality along with some ensemble learning. Ensemble learning means where a number of classification models are being used so to improve the performance. So Galar et al. Have attempted feature selection embedded into the different ensemble models. And by this method, they have increased the feature subspace diversity, and also they have the better performance. After that, Feng et al. In 2020 has a phenomenal paper where they have mixed SMOT along with adaptive boosting, that is an ensemble learning. So from SMOT, they have created the synthetic data, and that has been used with the ensemble learning, that is the ADA boost. After that, Gugri et al. Have used this MRT-PDP. This is the feature-specific decision trees, and they have used music rhythmic tree along with the SMOT. So all these methods have been mixed feature selection along with the different ensemble learning. In the same way, Ghosh and Roy have used entropy-based feature pruning followed by adaptive boosting and the SMOT. Then Lee have used the deep neural network along with random forest architecture. And they have also used the SMOT so to counter these two problems. The next paper that we have examined is Mohammed Spoor et al., where they have mixed SMOT with another ensemble learning, that is the random boost, and through the random forest, and through that they have examined the feature importance, and these features are being included. Nasri et al. In 2023 have used ADA boost ensemble learning combined with resampling with mutual information based on feature selection. So all these methods have mixed two different type of methodologies, one related to resampling and other related to ensemble learning. Then the third category that we have examined, since the most of the machine learning algorithm is being converted to the deep learning, when we have the large data set, so here we have examined the integration with the deep learning also. Like Bao et al. In 2020 have used K nearest neighbor along with SMOT, that is a oversampling technique, along with long short-term memories, right? That is a type of deep learning technique. So they generate high quality synthetic sample while preserving the basic structure of the sequential data set. Then Liu et al. In 2021 have used the hybrid model that was of SMOT, autoencoders, as well as recursive feature elimination. So to generate the sample as well as so to use the important features for the mixing. Then Zhao et al. Have used RFSTL algorithm, that is a transfer learning approach that integrates random forest-based features along with the SMOT technique. Zhu et al. In 2021 have used generative adversarial network embedded feature selection pipeline for the minority oversampling. So in this manner, they have enhanced the minority classes as well as they have go for dimensionality reduction. After that, Metra et al. In 2021 have used TSNE for dimensionality reduction, as well as this the another type of adaptive systematic sampling, so to improve minority class representation. And as we go forward, there are more work where a number of deep learning algorithms has been mixed, like Por et al., Jadhav and Raj Purohit, Ahmed et al., Lee et al., Fan et al. In 2022, where they have mixed a number of deep learning algorithm, including GAN, along with the different oversampling and undersampling technique. So they have obtained the better results. And if we go with the very current research papers, so even Saklan et al. Have used transfer-based hybrid sampling methodology, evolutionary algorithm that is a bit beyond the deep learning algorithm has also been attempted by Kohn et al. Ahmed et al. Have used two-step hybrid model. One is they use lasso for the feature selection and RU's boost for handling the imbalance. In the same way, Avon et al. Have stacked diagnostic autoencoder along with class awareness sampling. Lee and Zhang also have mixed a number of methodologies so to improve the better results. So, what is the conclusion of this review paper, where a number of work has been examined? It synthesizes a broad spectrum of hybrid methodology. So to face the twin challenges of imbalance as well as the high dimensionality of the data. So that comes a barrier to model generation, and they have impact to model accuracy, minority cross recognition. Emphasis is based upon algorithms as well as their performance and the application in various domains. Because the domains in which these approaches are being used are the critical domains where we have the high stakes are there and we have not much representation is there. And trend has observed that hybrid models have much better performance as compared to using single standalone solution separately for the two problems. And these methods not only improve minority class detection that are the underrepresented, overall classification performance has been increased, and they also reduce the model complexity, including that actually consists of using less number of features. Since less number of features are there, so the interpretability has also been increased. And as it has been mentioned that they are being very useful for the high dimensional data. So what is the purpose of this review paper? It aims to serve as a practical guide for the researcher as well as for the practitioners so that they can use hybrid model of these different types for the different situation. So their performance of the model is being improved as well as they have the better interpretation. And what are the future direction? So focus should be on developing scalable, domain adaptive and explainable hybrid models, because in the different domains, different algorithm will be useful that can handle dynamically evolving data stream where we have a high dimensional data sets are there, and to establish standardized evaluation protocol, because for SLC evaluations matrices are number of evaluation matrices are there. So there is always an issue on which they are to be concentrated. And finally, the integration of causality aware feature selection, AutoML pipeline, and fairness awareness model will be essential as we are focusing more on explainable AI. And these are the some of the references. Thank you.
Thank you so much for nice talk, sir. This review article downloadable? It's a preprint available on archive or not? No. I'm just talking about the review paper you are just mentioning here. Okay. Uh-huh. Okay, thank you, sir. And one more things you mentioned here, the high dimensional data.
Yes.
space. So the higher dimension, that means the traditional understanding of the dimension, that is the 3D or 4D or n dimension in the string theory, that is related to that or something.
Oh, no, high dimensional is we have number of features, right? Like you can say,
Yeah, no,
like suppose we want to detect why the frauds happen. So there may be n number of reasons. There may be financial reason, there may be social reason, there may be economic reason, right? So when we have large number of features, right? That is a typical problems with the current data set, right? That we have a number of variables are there that may be affecting the y variable. So here we actually means high dimensionality means we have number of features and how that is being related to the geometry because we develop the model. So obviously if we have 10 features, then there will be 10 dimensions will be involved. So in that way, both are similar, but they are the domain specific. High dimensions means number of independent variables are too
okay,
large.
so that is the degrees of freedom, I think, where you are going to
Because
interpret
we
it.
express them, if we express them in a geometrical n dimensional space,
Uh-huh.
so that become
Oh,
equivalent.
that's fine. So I will happy to see once the review article will be
Definitely.
published. And one is a small question I would like to ask you, how this is related to the topological data analysis.
Yes, in the topological data analysis, the topological sample that I have
Yeah.
mentioned, right? Because we use we try to use
Uh-huh.
what is the issue? Suppose we have 10,000 samples are there.
Oh.
In the 10,000, only 10 cases are there where we have the fraudulent activities.
Right.
Right. If we go with the 10 samples of one category, our algorithm or our solution will be highly biased. So what we do, we try to create the synthetic sample so that we increase the size of underrepresentative sample, right? So for that purpose, the topological data analysis or the topological sampling will be useful.
Okay.
Because we use the same distribution that is there related to that data set.
Okay.
So it is very much related to, some of the algorithm are very much related to topological data analysis.
So you included this one in this review article.
Yes, there is a paper, just a moment. Yes, like Hang have this methodology, right? So it combines PCA with topological. Topological sampling comes under topological data analysis. Okay.
Okay, thank you so much, sir. I'm
Thank you.
definitely very happy once the review article will be published.
आपका stream क्या है?
Actually, I'm working the quantum gravity
Okay.
and string theory, but I'm little bit interested in that.
Obviously, as we go with the data analysis, now amalgamation is everywhere.
Yeah.
Even the current Nobel Prizes, both in the physics as well as chemistry, calls for the integration of the different domains.
So recently, I'm just collaborating with Mishra. He's working, is the expert in the topology. So
Okay.
algebraic geometry like that.
Right.
Thank you, sir.
Thank you.
Thank you, sir. Thank you for the wonderful talk. I have a query regarding oversampling and synthetic minority oversampling technique.
Pardon?
Uh,
Which?
I have a query regarding oversampling technique and synthetic
Minority
minority
oversampling.
oversampling. Sir, both are same, but how they differ?
In the synthetic minority oversampling, that is an improvement over the oversampling because we create a function. Mostly we use a linear function. So to increase the number of the undersampled cases, right?
Small cases.
High small cases, undersampled cases, right?
Sir, in disease data, actually, we have the positive cases, very small.
Obviously.
In such cases, we use this small technique, but
SMOT is an improvement over oversampling, right? In the oversampling, we simply increase their number, but when we go with the SMOT, then we create either the linear function or the quadratic function. So we generate the
synthetic data.
synthetic data.
But actually, sir, I want to know, is that correct in disease data handling that we are using?
You can say that it may be possible that if we go with with the data sets, it won't be that much. But if we don't have the data, right?
Yes,
If
yes.
we have some rare disease,
Yes,
right?
yes.
So if some rare disease, we don't have
Enough data.
data set.
Yes.
So we have to create the data set. So for that purpose, it is being recommended that use the same probability distribution. So that's why SMOT is not only useful, like the topological sampling is also one of the methods, right? So in that way, we try to mimic the original data set,
Yes,
but
yes.
they are so tiny in numbers. So obviously there will always be an issue how they can be imitated. So there is a challenge. So that's why so many authors have worked on that.
Thank you, sir.
But at present, we recommend that we should go for the SMOT.
Thank you. Thank you, sir.
आपका background, you are
Sir, I am a research scholar in the Department of Statistics, Banaras in the university. Thank you, sir.
thank you.
Thank you, sir, for your enlightening presentation. Also, now I would like to welcome our session coordinator, Dr. Ajay Pratap sir, who has joined us now. Sir is working as an assistant professor and head research cell in Amity Institute of Information Technology, Amity University, Lucknow campus. He is a recipient of University Gold Medal for Master of Computer Application Program by Chairman of University Grants Commission. Sir is an emerging data scientist and cybersecurity expert who has published more than 25 national and international research papers and has been granted with national and international patents. Thank you, sir, for joining us in this session. Now, it is my privilege to welcome our next speaker, Professor Dr. Abhishek K. Singh, sir, Professor at the Material Research Center, Indian Institute of Science, Bangalore. Sir has earned his PhD from Tohoku University, Japan, followed by postdoctoral fellowships at the US Santa Barbara and Rice University. He joined the Indian Institute of Science, Bangalore in 2010 as an assistant professor and is now a full-time professor at the Materials Research Center. A recipient of the Materials Research Society of Indian Medal, he has also held prestigious fellowships like the JSPS Postdoctoral Fellowships. His research focuses on two-dimensional materials, catalysis, defect theory, thermal and electronic transport, and mechanical properties of materials with expertise in machine learning and materials database generation. Though he could not be physically present with us today, we are delighted to have him joining us virtually to share his valuable insights.
Okay. Yeah, thank you very much. Let me begin by thanking the organizers for giving me this opportunity to present my work today here, especially Dr. Pooja, who has been very kind in
In the meantime, I would like Dr. Asita ma'am to felicitate Professor Dr. Masood Hussain Siddiqui sir.
Are you able to see my slides? Hello. Am I audible?
Your slides are visible.
Okay. So let me know when I can start.
Thank you, ma'am. Thank you, sir. Abhishek sir, you can continue your presentation.
Sure. Thank you so much. Thanks once again to
Sir,
the
your
organizers.
voice is
Hello, am I audible?
very low.
Can you hear me now? Hello.
It's
Yes, sir.
audible to the online participants.
Oh,
Sir,
okay.
the voice is clear, but it is very low.
Yeah. Okay, I don't know. Let me try to talk louder, but maybe if you can bring the
It is fine now. It is fine now.
It is fine now? Okay. Okay, so let me begin by thanking Dr. Pooja and the rest of the organizing committee for inviting me to present my work in this prestigious conference. So the title of my talk is a machine learning framework for knowledge discovery. As a researcher, as you all know, or educator, what we do every day when we enter in our lab, we try to develop or create knowledge or synthesize the knowledge. So there are several paradigms for synthesizing the knowledge. The first one was empirical. People will do experiment, observe it, and try to see and find out certain patterns, which helps them to choose next experiments which we should do. Another big paradigm shift happened when all the mathematical and physical laws came out. So, for example, mechanics, thermodynamics, everything evolved, including quantum mechanics, and people started to simulate or start to get the properties or phenomena and started understanding mathematically and then verifying it by experiments, or sometimes what they observe in experiment could verify by theoretical calculations. However, as soon as these equations came, people also realized that it became extremely hard to solve them. And then but then the computers came in, and that led to the third paradigm where people were able to simulate these equations and generate huge amount of data. So including, that led to also formation of computational material science, computational fluid dynamics. So many fields came out where people started using computers to solve this equation. And in this paradigm, which is essentially took off in the year 2000 onwards, we started generating a huge amount of data. So all along, the history of this doing science or creating the knowledge, we have been generating the data, and now this speed has increased even higher. So currently, as we speak, people are running this simulation across the globe. And also you would realize that there are many experimental techniques which also generate huge amount of data. So both from the computation part, of course, they are generating the data, but also all the sophisticated experimentalist or experiments, they are also generating the data. Now, these data can be a gold mine, and this is what people realize, and started using machine learning based tools or techniques to do the following. First of all, to find out again the patterns which have not been uncovered, and trying to do things which they have been traditionally doing in a much slower way. Can it be accelerated by using the data? So that's the regime or paradigm where we are in. Now, how do we use, so as the previous speaker told, that data science is actually started cross-cutting across the different areas or different domains of the science. So the important thing here is the problem statement, because whatever, data science, if you use, or theoretical science you use, or even experiments you use, eventually the problem statement comes from the domain knowledge. So it usually comes out from physics, chemistry, materials, biology. So you decide what you like to do first. What is the question? Then we can use, either computer science. We can take the help of our friends from computer science and technology, or learn it by ourselves, mathematics, statistics, informatics, and try to solve these problems just by data. Of course, traditional way of solving these problems are always there. But as I told you in previous slide, those are quite slow. So without boring you too much, I'll quickly tell you that how fast the volume of the data is currently being created. So this is the first line you see. Now, this is the line which shows how much information we are storing. So when we are doing an experiment, like let's say electron microscopy images, when we are taking, we are actually generating almost of the order of a terabyte data just to get few images. but we don't store all the terabyte. We will be just taking 1 or 2 pictures out of that. Similarly, when we are doing a simulation, we are at least creating the data of worth of gigabyte, but we are going to store just few MB of data. So that is what is known as the information stores. And now from this data, how much knowledge you have captured, basically what did you learn, and what you learn, is it repeatable? Can you apply it for unknown scenarios and still predict the outcomes? So that knowledge capture is the slower, is further slow. I mean, it's growing, but at much slower speed than the information store. And finally, the utility achieved. So after you got this knowledge, now can you apply it to create something useful, either through industry or in your lab, or the example of a Nobel Prize was given. So this is the slowest one. So we need to fill out this gap, right? So data is getting created very fast, rapidly. Information stored is fast, but not as fast as creation. So knowledge capture and utility achieved is the two things which we should be doing. So as it was told that I also work in the area of materials informatics. So anything you take, I mean, data science, as you start with, the word data science itself tells you that you need data, right? And this data in certain community is in abundance, but in certain community it is not. And even if it is there, it's spread across various, places, various labs, not organized in a very, very haphazard way. So we cannot, collect them together and create something useful out of it. So we decided to develop a database for a two-dimensional material, which is known as a Maxine. And back in 2016, it took us about 2.5 years to develop this database called Anand. So this is a materials database where you have more than 25,000 basic information of more than 25,000 2D materials. And this has put actually India in the map of the global databases. So if I strongly encourage the students to look at the Anand. It's freely available. So if you go there, you can click on Anand. It has, as I told you, a database about the Maxine. If you click, you can search which Maxine you want. It will give you the search based on their properties. There's a lattice parameter, band gap, etc. And then you can also look, the band structure. You can check whether it's direct band gap, indirect band gap. And if you want to download, you can download that. If you want to download the entire database, so we also allow that. You have to write one email to us and we will give you access to download the entire data set. Now, Anant has continuously evolving as we speak. So we have recently released the topological database. So these are the topological properties of material, which is stored. So probably this is one of the few databases which has such a comprehensive information stored for topological material. We also came across a new 2D materials, which is 2D octahedral materials database. This is also we have released for the community. Now we have the data, what we can do. So one example you saw that was related to the sampling in the previous talk, right? And we see different approach to sample things to do the classification. Now in materials world also we need to worry about the classification. So one of the important classification which we look for, whether a material is a metal or semiconductor, right? So if it is a semiconductor, it has a various application, right? If it's a metal, also has applications. So I'll try to show you some example from both. Now, if you see if I give you a piece of a metal, a material, I would not call it a metal, and ask you whether it's a semiconductor or metal. So one way to do it, you toss a coin, and if it's a fair coin, your chances of getting it, your guess to be correct is 50%. But if you use machine learning or if you use classification model, you can push your luck all the way to 99%. So you will have accuracy of almost 99% to tell whether the material which is in your hand is a semiconductor or metal. So this is the power of machine learning. And that's why we are even having a session here today. So what we are doing now, when we use machine learning algorithm, we start taking the decisions. Okay. Sorry about that. So The next example which I want to give you is related to band gap estimation, because all the semiconductor materials, they have a band gap. And generally, if you want to calculate the band gap, it's usually underestimated. Therefore, we need to get it accurately calculated. And this process takes a lot of time. So in order to accelerate this, we use machine learning models wherein you just tell the basic properties of a given material and it gives you the accurate band gap. So something which would take a week to get the accurate band gap, you can do it in less than few seconds. Another thing, the different application of semiconductors, it depends on where their band edges are. So these are like, VBM, this is your CBM, and how they are aligned from with respect to rest of the material. So to do this alignment, if you do with a traditional science, can take a lot of time, especially the database which I have shown you. But if you use machine learning based model, these both can be predicted fairly accurately, and you can do it again within a few seconds. So one of the goals of using machine learning in material science was to accelerate things. And you could see these are the examples where we can do something which will take easily a few days if we are just looking for one material. Imagine when we have to explore now billions of material, is how challenging it is. So at least one material, we can do it within a few seconds. Some other example where we start using physics informed models. So basically, we know the physics of a particular process, in this case thermal conductivity, and we derive the features directly from the physics, right? Although we know that we don't have any access to the exact model or science-based, very highly accurate model. Mostly they are a semi-empirical model. They do not perform as expected. So in those cases, what we can do is we can develop a machine learning model just by taking 4 parameters or 4 features. And with these 4 features, we can get a highly accurate model for the calculation of thermal conductivity, which again takes weeks to do it just for one element. So this is another example where things can be accelerated. And now, since we are using these physics informed parameters, therefore you have a huge interpretability. Now you can interpret the entire result which you are getting. Another example of choosing features which are loaded with core knowledge. So one I showed you about how we use the physics part. Other one, you can use some chemistry knowledge. For example, chemical hardness. Although chemistry, physics, these lines are very blurred nowadays, but chemical hardness is a property which is very, very important when two different type of elements, they come together and react and form a compound. And there is a principle called hard soft acid-base principle, which is built only on the hardness. So now if you take a hardness as your parameter, you can start predicting so many properties of chemistry, of a chemical compounds, and with a greater degree of accuracy. And also it gives you the biggest advantage which we get by using these features, that they are all highly interpretable. Now, I'll just quickly take you to the structural material, which are basically metals. So in the structural materials, here, there are 2 aspects. One is, of course, the chemistry of the material. So let's say we take an alloy, let's say steel. Steel has predominantly iron and some amount of carbon. Or similarly, there are other alloys like super alloys, nickel, cobalt-based super alloys. They can have all the way up to 6, 7, 8, 9, 10 elements. So how we are going to map their properties, if suppose we have access to the database, to their structure or to their chemistry. Now there are 2 aspects. So these structural materials have their properties depends on 2 parts. One is their atomic structure, so how the atoms are arranged, and also what atoms are there. So whether it's a nickel cobalt, whether it's a nickel copper, so that decides what would be the property. Furthermore, all these alloys, because these are structural materials, so whatever structure you see around you will have one or the other type of structural material involved. And they are mostly metals. Depends on their microstructure. So when they process it to form, let's say, in the iron case, if you want to develop a TMT bar, it will have its microstructure, which also plays an important role in deciding the element, its mechanical properties. So basically, you need to know their elemental and compositional properties as well as microstructure to be able to predict the property. And then we can use this in the machine learning models and find out the different properties. But the biggest question is the microstructure which we see, they are just images, right? So how do you match an image? This is a scanning electron microscopy image. Now this image to a property, it becomes extremely challenging. And okay, you can say now deep learning can, can help you because they are meant to read the images, but it's not an image of, dog, cat, or people, which has a, fixed form. Here, these are the microstructure which evolves, and different metals, different family of, alloys will have a very different class of microstructure. So in order to do that, we need to represent them. Okay, so we need to make this structure computer readable, right? Or we have to basically featureize it. So let's quickly come to what we have done. So this is we take our SEM images and we use what is known as a image processing technique. So here we binarize it. So you could see that these are the darker ones are the gamma phase, and the gray ones are gamma prime. So this is a two-phase material. It has a gamma and gamma prime. Gamma forms a matrix, and gamma primes are the precipitate. And because of this microstructure, because these are precipitate, they block the dislocation movement, and hence their mechanical properties are very, very good. And nickel and cobalt-based superalloys are the one which make us all travel very safely, because these are the one which are used in aircraft turbine blades in their engine. So these are extremely special class of alloys that are used at a very high temperature, and they retain their structural integrity and also their mechanical properties. So what we do, we take their SEM images, we collect them from the literature or from our experimental friends, and then we binarize it. So when we binarize, which mean to say that we set up some cutoff. So below that, everything becomes black. Above that, everything becomes white. So now we have a very clear 2 pixels, right? 2 colors of pixel. One is black, one is white. And in this case, luckily, because these are, and these pixels have meaning also, they are representing 2 phases. Now what we do, we calculate the correlation between these 2 phases, black and white pixels, white and white, black, black. And then when we do this correlation matrix, when we develop this correlation matrix, it depends on the size of the image. So if let's say this is a 256 by 256 image, then you get a matrix of correlation matrix of 40,000, which is quite large. So we need to reduce it. So we are going to use the PCA. So we take this matrix, we use the PCA, and we find that if we take about 25 principal component, they are good enough. They capture almost 80% variance in the data. So from out of 40,000, by applying the PCA, we have now reduced to just 25,000. Sorry, 25 PCAs. And then we use the compositions. What are the elements which goes? Nickel, iron, cobalt, rhenium, whatever it is. And then we combine these two and build a model. So if suppose you take just PCA and build a model, those models perform really poor until you add the chemistry information. So the moment we add the compositional analysis and some processing, we get a very good model with a very, very high accuracy. Now here in this case, we also did something else. So when we binarize it, actually you start seeing these geometric shapes which are coming. Some of them are square, some of them are rectangular. So we can do some, we can featureize it using geometry. So we take this image and we start calculating the effective area of, let's say, white part or black part, effective perimeter, effective radius, effective volume fraction, just from this image. We pull this out, mix it with the composition again, and get a nice model. And these two models actually can cross-validate each other. So something which you have calculated from this approach, you can test it from this also. And many times, most of the time, they agree very, very well. Now here, for this particular alloy, it was simpler because we have a clear 2 phases, and hence image processing helped us to do that. Now, if we start going to the processes which involves much more complicated phases, this approach essentially will not be able to help us. And hence we have to move to the deep learning based method. So here what we did, we use CNN to capture the microstructure to a quantity, we are calling it right now RM. We are mapping this microstructure to RM. And we took the composition also and train another ANN and map it to RC. Okay, and then we concatenate these two through a weight. So this is also trainable, and then which finally gives us the hardness. Now this architecture is we have developed this architecture actually. So this architecture has again physics embedded into it, because this part which you see mostly depends on the composition. It relates to a very important phenomena in this alloy, which is a solid, also known as a solid solution strengthening. So what happens, these elements, they would go into this matrix and they either generate the strain, either compressive or tensile. And because of that, the dislocations motion becomes harder, and hence it is strengthened the material. The other one, which comes from the microstructure, which you see here, that is called as a precipitation hardening. So basically, we are mixing the solid solution strengthening and precipitation hardening, combining them together to get the hardness. So we can, even though it's very hard to interpret deep learning model, but here the architecture is such that we are able to even interpret it. So I'll show you in a minute how we do that. And when we deploy it, we got a very, very good RMSE for test train as well as for the validation side. So here you could see, and this network which we have developed is also very light. It has just 4 million parameters. Nowadays, there are models which have 1 billion of the parameter, but this is just 4 million parameter. Quite light model, can run on a simple desktop and give you all the information which we are looking at. And this model, fortunately, not fortunately, by nature, starts working on different kind of SEM images. So for example, for titanium alloy, which does not have this two-phase separation. So titanium alloys has a much richer phase microstructure, but it got trained and it started predicting the properties of titanium alloys. Now we are training it for the steel and iron, and I will update you as we move forward. Now let's look at a little bit interpretability. So what you see that here, the green dot, these are the predicted hardness, and the red dots are the contribution from the composition, and the blue one is contribution from the microstructure. So you can see that most of the hardness actually come from the composition, which is expected because the chemistry is the one which determine. So two elements, how strongly they bind, will tell you whether it's hard or less hard. But the variation which you see here, that is basically comes from the microstructure contribution. So for example, we picked up 2 data points randomly where the compositional contributions were identical. So 4.39, 4.39. Now, when we look at their microstructure and look at their, the microstructure contributions, we see that there is a huge difference. One has 0.96, other one has 0.26. And hence, it can easily predict the 2 different hardness. For example, one has a 5.35 and other one had a 6.65 gigapascal. So this way, we are able to now capture why certain things are giving us more hardness and certain things are giving us less hardness. So finally, now since we have developed this model, we can also try to help our experimental colleagues. How do they go and process their material so that they can get the a given mechanical property. So this is the model where what we have done, we have fixed the composition and we start playing with the shape of these precipitates. And what we find that the precipitate size has peaks. So you cannot continuously grow the precipitate, then the property drops, but it can work up to certain point quite well, and there is a maxima with respect to that. Similarly, with respect to volume fraction also, so we can basically optimize all these properties and able to tell what are the things which our experimental friends should do to get a most optimized mechanical properties, including, if they can start controlling the shape of these precipitate. If they are more rounder, it's harder to destroy. compared to, if they have a sharp edge. So with that, I will stop and I'll take any question which you may have.
Good morning, sir. This is
Fine.
Dr. Singh from NIT. It was a wonderful talk and definitely from your talk, our students, especially who are doing the research in this area, will be benefited.
Thank you.
Thank you very much, sir, for this wonderful talk. And there are a few questions which students want to take.
Sure, please.
Good morning, sir.
Good morning.
Sir, my name is Adil Singh and I have a question.
Uh-huh.
Sir, how can these functional materials improve energy storage devices?
Energy storage device. So one example which I showed you. So your question is about the materials or
Yes, sir, materials, functional materials.
functional materials, all the materials which are which have certain functionalities. Those are first of all called functional materials. So for example, semiconductors are functional materials. So you can dope them, you can tune them properties, and polymers are functional materials, wherein we can, if we like, we can tune their functional properties, not just the mechanical properties. For example, we can change the conductivity of polymers. Similarly, even 2D materials are functional material. So now, depending upon which application you are thinking, you are keeping in mind. So suppose you want to develop a highly efficient photovoltaic, so you need to, but that photovoltaic, as you know, it's not just a one single material. So it has, of course, the core, which is a functional material, but then it has several other layers. And then you need to optimize, you need to find out that in the presence of all these materials, what would be the effective, efficiency of your photovoltaic. So, and then you choose this material. And that decision is taken by my first part of my talk where I showed you. First, you need to know how much is the band gap. It must lie in the optical region. Second one, where are these VBM and CBMs? Because that's very critical, because when you form the next interface, these VBM and CBM is going to align with that next material. So you need to know also the VBM and CBM of that material. So that's where that model is very useful, because it can map it out where the VBM and CBM are, or for a metal, even the Fermi level are. And then you can align them in such a way, or stack them in such a way that you get a highly efficient solar cell. So that is one example. Similarly for batteries, if you want to generate a cathode material. So here I wanted to say one more thing. When we look at the materials, we have, especially in the search community, we look most of the time in a isolation that, okay, I got this one functional materials, it does great in my lab, and hopefully it will change, it will work, it will change the world, but it doesn't work like that. Materials to device is another journey. So suppose you found a material, but how it is going to behave. So for example, in the batteries, which is another storage device, there, lithium-ion batteries, the graphite is the anode, and it's been there from forever. And there are thousands, I would say even hundreds of thousands of papers are there where people have proposed the alternative of graphite, but none of them can beat graphite, because it's not just one property on which makes graphite or graphitic electrodes anode very, very special. There are many, many things. Graphite has a very high electrical conductivity. It has also high thermal conductivity, which helps to release the heat. It forms a solid electrolyte interface, so which is essentially the God's gift to mankind. Because of that, you have this stable battery performance in the lithium-ion battery. Now, if you replace it with some other material, let's say silicon, will it have all the things, or it just stores the lithium in a large quantity and it's done? No, storing large quantity of lithium is one of the property, which of course graphite has, but there are many other things which makes a particular material finally applicable to the applications which we are using. So we need to be very careful when we do our research. We can tell that, okay, yeah, now we find tin which can store a lot of lithium, but can it really work as an anode? That we cannot comment unless you put it in a battery and test it. Does it meet all the criteria which graphite has? Same thing with silicon. And therefore, the last point, there are only very few materials out of these billions of material, literally billions of material, which we use for our application. So silicon is one of them. So it's impossible to replace silicon even till today, because it's not just band gap of 1.2 eV. There are so many other things for silicon is so right, which is again, it's a God's gift to us. But if we want to get that or search what are the other things which nature has for us, we need to look at more holistic or more, from the device perspective, and then search for the material.
Hello, good
Hello?
morning, sir.
Yeah,
Sir,
good.
myself, Prachi Mishra. I also have one question. How
Yeah.
long before we see commercial devices based on these materials?
Sorry, how much? How long?
How long before we see commercial devices based on these materials?
Okay, commercial devices takes a long time. So for example, we use the term whiteboard. So when we start, discussing with my student, okay, let's work on this particular material. From there to your computer, it takes 20 to 30 years, 20 to 25 years. Now our hope is with the advent of data science, machine learning, to accelerate this journey. Now it should not take, let's say, 25 years, but can it take just, few years or few months even? So this is the challenge on which, where we are using machine learning very extensively. And there are some success, but, it's still a small amount of time to comment on that, how much it will accelerate. It will definitely accelerate, but, whether it will cut down this 25 years to 10 years or 25 years to 10 days, yet to be seen.
Hello.
Hello, yes.
Hi, Abhishek.
This is
So just one question.
Yeah.
Because I saw that you have used images from the experimental studies, and then the thermodynamical considerations were only taken. What about the kinetics?
No, we see, this is data science. So we're not exactly including all the direct science things. So if you put the thermodynamics, kinetics, then you don't need data science, right? So
Okay.
kinetics is anyway very hard, because when you do the microstructure, when you do the processing of these materials or the alloys, so they heat it, they annihilate, then they cool it, sometimes very rapidly, sometimes, with they have what is called an aging process. So they will keep it at certain temperature for few days and then bring it back again. So all these things are essentially takes care of the kinetics. So you want to trap the I think I told, but I believe all of you know that the material fails via dislocation, right? So, and then you need to hamper the motion of dislocation. You have to impinge them. All the materials will invariably have the dislocation. So what makes a material very special, how hard it is for the dislocation to move around. If they move around and if they come together, then they will destroy your material. But if you can impinge it, so that is where the processing part comes. So our hope is, so we replace the kinetics, or we try to capture the kinetics from the image, because those images inherently have the information of the kinetics. Otherwise, if we have to, from the pure science, traditional science, we have to include the kinetics. If you do the molecular dynamics simulation, I don't think it's possible, because those images are almost centimeter sizes, or
Yeah.
at least millimeter sizes. So it's just billions of atoms there. So very, very hard. Yeah.
Thank you so much. Thank you.
And thanks
Thanks.
again for the invitation.
Thank you very much, sir. Your time for this wonderful talk. We really appreciate your approach. Thank you very much.
Thank you, sir, for your excellent presentation and for sharing such cutting-edge perspectives. It was indeed enlightening. Now I would like to invite Professor Dr. Amrish Kunwar, sir, professor at the Indian Institute of Technology, Mumbai. Sir is a professor at the IIT Mumbai. He completed his PhD from IIT Kanpur in 2006. He was a postdoctoral fellow at the US Irwin for 2 years and then at the US Davis for 4 years. He joined IIT Bombay in 2016. His lab, which includes more than 10 scholars and postdoctorals, is engaged in both basic science-oriented as well as technology development-oriented research. He is the recipient of many awards. To name a few, Professor S.P. Sukhatme Award for Excellence in Teaching 2025, Young Investigator Award for ICF UST 2025. Sir would be joining us virtually to share his valuable insights and expertise.
Good morning. Can you hear me?
Yes, sir, you are audible.
All right. Should I share my slides?
Yes, sir, you can proceed.
Sure. I hope all of you can see my slides, right?
Yes, sir.
All right. Should I start?
Yes, sir, you can
Okay.
start the presentation.
Okay, so thank you very much to organizers for giving me opportunity to talk about my work. So today what I'm going to talk about is robotic, non-robotic and IoT based systems for surface and air disinfection. And I would like to very specifically tell you that this is a new area of research that we started in our lab about 5 years back during the pandemic time. So just a little bit about my lab. So in my lab, we work on both basic science as well as technology development. On basic science side, we work on transport and force innovation by a group of molecular motor proteins. We do both experiments as well as Monte Carlo simulations. Then we also study the interaction of various antimateric drugs with microtubule using molecular dynamic simulations. And we also study different kind of proteins which are involved in endocrine diseases and disorders, again in collaboration with clinicians at KM Hospital in Mumbai, again using the molecular modeling as well as molecular dynamic simulations. Then on the technology development side, we train the people how to make low-cost microscopes. We have been developing both robotic as well as non-robotic UVC-based disinfection devices. And this is what I'm going to talk about today. And we also work on another spectrum of UV, which is called for UVC. I'm going to tell you a little bit about it because this a very new area of work which is happening in the country. And we are also working on developing IoT-based systems for indoor air quality. And there is also a new area that we have in the lab, which is neurorobotics, where we try to combine the robotics with the neurobiology to understand a lot of problems related to neuroscience, such as tremors as well as change in gait patterns during the neurological disorders. All right. So we know that pandemics are not new, and there are a lot of pandemics that have happened in past, and they have taken life of many people. For example, this is the last year's statistics that COVID itself killed about 7.1 million people worldwide. So we have seen one of the airborne infection, which was COVID, and we also know about the other airborne infection, which is influenza, which keeps happening every year, and it basically takes life of a lot of people worldwide, the seasonal flu. And there are different ways in which a person can get infected because of the pathogens. It can be either through aerosols, for example, when some infected person due to flu, TB, or COVID sneezes or coughs. So one of them is airborne transmission. The other way of transmission is basically these aerosols get deposited on the surface. You touch the surface and then you touch your nose or mouth and you get infected. So there are different mechanisms by which people can get infected, and there are different ways to sterilize the things to keep you safe from the pathogens. So many people use dry heat sterilization, then steam sterilization, which is very standard in clinics, autoclaving, which is nothing but using a pressure cooker at a very high temperature. Then a lot of people were using chemical sterilization during the COVID time, alcohol, bleach solution, sodium hypochlorite. Then filtration, for example, all of your air filters in AC and fans do the filtration, which depends on the mesh size. And then there are also gas-based installation method, ozone-based, hydrogen peroxide-based, which are generally used in the industry. Then for very high grade installation, people generally use ionizing radiation, gamma radiation, and X-ray. These are generally used for medical equipments and surgery. And then one of the very popular method of installation is using the non-ionizing radiation, and that is the UV radiation. Okay, and most of the talk is today based on the UV radiation and its application. So UV radiation has a large spectrum, and the entire band can be divided into UVA, UVB, and UVC. And in general, in most of the devices like your water purifier and many other things, use something called germicidal UV, which comes into the UVC band. It is 254 nanometers of spectrum. So UV radiation kills the pathogens by a very unique mechanism. What it does, it basically interferes with the replication cycle of the viruses, and it blocks the replication cycle of the virus, and that's how it kills the pathogens. And UV radiation, and how much pathogen or the quantity of pathogens that will be killed, or the number of pathogens that will be killed, depends on how much dose is received by these pathogens. And that is something which depends on what is the irradiance of the radiation and for how much time you are exposing it. And generally, the killing of the pathogen is measured in something called in the units of log inactivation. When I say 1 log inactivation, that means you have killed 90% of the pathogens. 2 log inactivation means 99% killing. 3 log means 99.99, and 4 log is 99.99% killing by any method. So generally for most of the commercial devices, we generally go up to 4 log inactivation. And this table shows that, UV dose has been measured for different kinds of bacteria, virus, yeast, spore, protozoa, and algae. So UV radiation can kill all kinds of pathogens which are harmful for us. And UV disinfection is not something which is new. This is there for a very, very long time, for last 50, 60 years, or maybe even more than that. And it has been used very heavily in the purification of the water in different sectors, purification of the air, as well as surface. However, this was not available for the domestic use during the COVID time. So you might recall that the COVID was announced on March 24, 2020, and the first paper that came that UVC radiation can kill the SARS-CoV-2 virus, which was causing COVID-19. It came after a year on March 18th, 2021, after 1 year from the date of lockdown. However, at IIT Bombay, what we did within just 1 week of lockdown, we came up with the idea of making the UV-based disinfection units, which can be used in houses. And this was the first prototype we developed, and we went public with that news. And a lot of people across the country like this. And this was not something which was based on, random guess. This was based on already known science of the UV radiation. So it was already known at that time that UV radiation can kill different kinds of emerging viruses like SARS-CoV-1, Nipah virus, and some other kind of emerging viruses. And we look at the data from the literature, and then we came up with the idea of developing these units which can be used in houses. The other problem that was happening during the COVID time, people were mostly using soap solutions, alcohol-based sanitizers, and they were ruining a lot of electronic devices, especially cell phone. And there are many materials which are not suitable for wet installation. So UVC-based installation is one of the very very standard method for installing these kind of devices. So we developed this, we went public with this, and a lot of people picked up our idea. In fact, in the Indian Navy started to use our prototype to build their own prototype. They acknowledged it, and it appeared in a lot of newspapers, also came on few TV channels. So all of these units were like non-robotic units. So they were like boxes which can be used for the installation. However, we were also asked to develop the robots which can be used for the installation. And these robots were not available in the country at that time. Just 1 second. So these robots were not available in the country at that time. So what we did, we first developed the kind of robots that were already available in the overseas markets. For example, these kind of robots were available, but for a very high price, for about 1.5 million rupees. And no one in India was making them. So what we did, we basically developed these units from scratch in our lab at a very, very low cost, in about 50,000 rupees. And one of the problems with these kind of robots which have ultraviolet lights, but these ultraviolet lights cannot be moved. And therefore, they are not very efficient in doing the pathogen inactivation, because ultraviolet light will kill the pathogen only when it directly falls on the objects. If you have this kind of design, if you have a room like this, then ultraviolet light will have a lot of shadow zones. And in the shadow zones, it will not kill the bacteria and viruses. So to overcome that challenge, we came up with another design for the robot, which is called the robot with movable arms. And these robots with movable arms have the arms which can fold, unfold, can move up and down, and that's how you can navigate all kinds of complex surfaces in a room. And we also applied for a patent for this invention, and we have got an Indian patent for this device. And now we are looking for commercialization of this device. However, all the non-robotic units that we developed, we already commercialized it during the COVID time. And we also did a comparative study of this kind of robots which are available commercially versus the new design of the robot. And what we find, doing both experiments as well as theory, that the robots with the arms perform much better than the robots without movable arms. Now, after the COVID, people have become very careful about the quality of the indoor air, because quality of the indoor air directly influences the quality of life and human performance. For example, if the level of CO2 in a classroom goes up, then the attention span of the people decreases, the amount of drowsiness decreases. So CO2 is a very important factor, and if there are pathogens in the room, some people are sick, they are sneezing, then they can infect the entire room, and therefore the ventilation, indoor ventilation and indoor air quality is a very important thing. So right now we have a project which is funded from TIH at IIT Bombay. And right now we are developing the IoT based germicidal UV disinfection units. The idea is that if we have a large campus, we can mount these UV GI based disinfection units, which are connected to each other through a IoT system. And we can control the quality of the indoor air. We can look at various parameters such as CO2 level, volatile organic compound level, relative temperature and humidity. Because earlier the comfort was only known due to two factors, temperature and humidity, but people were ignoring the other things. For example, what is the PM count, what is CO2 level, what is VOC level, and what is the pathogen load. So we are designing right now a IoT system which can monitor all of these factors at the same time, and you can have a overall idea about the quality of the air that is present on the campus. So this was all about the germicidal UV radiation, but there is another spectrum of UV radiation which is called far UVC radiation. This UV radiation has a wavelength of 2 to 2 nanometer, and what is known about this UV radiation, that this gets reflected from the dead layer of the skin and tear level of the eye. So if you are talking about the conventional germicidal UV radiation, which is 254 nanometer, if it cannot be used in presence of human beings and animals, because if you get directly exposed to it, it will cause the cancer, skin cancer, and it will cause the cataract in the eyes. But this particular radiation, which is 2 to 2 nanometer, is supposed to be very safe for the human beings and animals, and therefore you can use this in presence of human beings and animals. You can mount them in the operation theaters, in the doctor's chamber, and in TB hospital, and they can do the continuous disinfection. So what we have been doing, that we are trying to do the basic science with this far UVC radiation. We are trying to study the efficacy of this particular far UVC radiation for inactivating different kind of pathogens in comparison to the traditional UVC, which is 254 nanometer. So we know that this far UVC can inactivate the pathogens with high efficacy, for example, influenza virus, even coronavirus, and it doesn't produce the DNA damage and doesn't cause the cataract. So we have constructed a far UVC based tunnel for the disinfection of the people, and we also have Indian patent for this invention. And we are again trying to commercialize this invention. Now, when we talk about the viruses, there are different kind of viruses. For example, there are DNA viruses, there are RNA viruses, there are double-stranded DNA viruses, single-stranded DNA viruses, single-stranded RNA viruses, double-stranded RNA viruses. So there are about 8 different groups of viruses, and we are trying to understand whether far UVC radiation is effective in eliminating different kinds of viruses which have different kind of genome as well as different kind of size as well as different kind of analog. So what we did, we took the viruses with different kinds of structure as well as genetic material, and what we found, just to summarize, we have already published this paper, and we find that this far UVC radiation can inactivate the viruses which have different kind of genomes. For example, single-stranded RNA virus, double-stranded RNA virus, double-stranded DNA virus, single-stranded DNA virus, with an efficacy which is much greater than the conventional germicidal UVC. Now, other than that, we are also looking at the efficacy of this particular far UVC radiation in activating the viruses which are present in aerosol. So people have generally done it with the buffer solutions. So what we have done these studies with different kind of viruses, specifically with 2 different kinds of viruses. One of them is called 5/6, the other one is called MS2 fast. So what we did, we aerosolized them in buffer solution as well as in artificial human saliva, because when you are sneezing, when you are coughing, all of these viruses are enclosed in a saliva, and they have a protective layer around it. And we try to study the efficacy of both UVC as well as far UVC radiation in presence of artificial human saliva as well as buffer solution. And we have designed the experiment as well as we have conducted the experiment. So what we do, we basically culture the viruses, we aerosolize them, then we correct them using a air sampler at different time points, and then we do something called plaque assay to calculate how many of viruses are surviving after the UV as well as UVC exposure. We have again published this study very recently in photochemistry and photobiology. And what we find from our experiments, that again, using both 222 and 254 nanometer could considerably accelerate viral biosolid activation in artificial human saliva or in SM buffer. And for 222 nanometer exposure, 5/6 were more susceptible in artificial human saliva than the SM buffer, but MS2 fast was equally susceptible in both of the cases. And what we also find that 5/6 and MS2 were more susceptible to 254 in artificial human saliva than the SM buffer. But we have to do still more basic science to understand the exact mechanism of inactivation due to the presence of the artificial saliva. So this is what we are trying to explore right now. With this, I would wrap up my talk. I would like to thank some of the students who have worked on this. For example, Monica has done most of the work related to UV and far UVC radiation, as well as development of robotic and non-robotic devices, and she is graduating soon. My collaborators for all the pathogen inactivation experiments were Professor Kiran Kondavagi, Professor Leena Machani, and Angun Guha at IIT Bombay, as well as Professor Samik Singh. And I'm also looking for project staff and postdocs who are willing to work on different kinds of interdisciplinary problems that are that we do in the lab, and they are the various funding sources that keep my lab funded all the time. So thank you very much, and I will be happy to answer any questions you may have.
Thank you very much, Dr. Amrish. You are true ambassador of Apta Mein Avsar. Great talk on UV sterilization and IoT-based air quality monitoring system. Definitely, this is a new area of research, and many of us are motivated by your talk and will definitely collaborate with you in future. There are few questions by our researchers. So, over to students.
Good morning, sir.
Good morning.
Sir, my name is Ritika Singh and I'm pursuing BTech in biotechnology. So my question is, we often come around terms like sterilization and disinfection as well when we talk about the instruments in the laboratory. So I want to know what is the basic difference between sterilization and disinfection?
Okay. So there are three things. Actually, there are four things. One of them is called cleaning. Cleaning is just removing the dirt. Disinfection means you are using some, industrial chemicals to kill the pathogens, but you are not eliminating all forms of life. You are taking it to a lowest possible level, okay, by using, let's say, phenyl solution or something. But sterilization is something where you are getting rid of all forms of life, okay. Generally for surgery, other things, you don't want any outside microorganism to go inside the body. So in this case, you have to do the sterilization, and that is generally either done using the gamma radiation or using the autoclaving. So any surgical instrument that has to go inside the body, people first autoclave it. So sterilization is basically is equivalent to getting rid of all forms of life. All right. Disinfection doesn't guarantee that.
Thank you, sir.
Yeah.
Thank you, sir, for your engaging and thought-provoking presentation. Your contribution has added great depth and value to this session.
All right.
Now,
Thank you very much.
I would like to request our session chair, Dr. K.K. Singh, sir, to please come up and sum up the session. Please, sir.
Okay, thank you very much for inviting me in this technical session. It was a wonderful session with three of these speakers talking in different areas of their research. And definitely the students who were sincerely attending this conference will be benefited by these kind of talks. And I appreciate the organizers and all the coordinators who have done a wonderful job conducting these kind of conferences. My best wishes for the next sessions.
Thank you, sir.
Okay, thank you, Dr. K. Singh sir and Dr. Ajay, who has very well consented with for the chair session. And it's really nice to have the people to support us. Thank you so much for gracing this occasion. Thank you.
I would request our HOI ma'am of ASA's department to please felicitate our session chair, sir. Also, I would request Pooja ma'am to join them. And all the faculty members to please join them. Thank you, everyone. We will now have a short tea break for 15 minutes. I request everyone to reassemble again at 12:10 as we continue our journey of learning. The dignitaries can have their tea in front of MPH, and all the participants and coordinators are requested to have their tea at the back of the auditorium. Welcome to our session chair, Professor Dr. Masood Hussain Siddiqui, sir, and our coordinator, Dr. Shivam Shukla, sir. Sir, holds a PhD in statistics, specializing in survey sampling, and is currently serving as an assistant professor of statistics at the Amity University, Lucknow campus. He has published 12 research papers in reputed international and Scopus Index journals, contributing significantly to the advancement of statistical methodologies and applications. Sir is passionate about mentoring students, fostering research collaborations, and promoting the use of statistical tools for solving real world problems. He has actively participated in national and international conferences, workshops, and seminars showcasing his work and engaging with the broader academic community. Thank you, sir, for your presence in this session. Let us now continue with session 2, Statistical Techniques in Advancing Sustainable Development Goals. To begin this session, I am delighted to invite Professor Dr. Jayadevan Sridharan Sir, Professor at the Gulf Medical University, UAE, to share his valuable insights with us. Sir has over 30 years of experience in research and academics. Sir has served as lecturer to associate professor at the Academy of Medical Sciences, Kannauр, and as assistant director and professor at the Gulf Medical University. Currently, he is professor of epidemiology and biostatistics and program director of the MPH program at the Gulf Medical University, UAE, besides being an adjunct professor at the University of Arizona, USA. With over 150 publications, he is a reviewer for international journals and an active member of professional bodies, including the Association of UICC Fellows. It is my honor to invite Professor Dr. Jayadevan Sridharan Sir to deliver his presentation virtually.
Good afternoon, all. Can you hear me?
Yes, sir, you are audible.
Great, great. Thank you, dear. Thank you so much for your introduction. And I will get the 30 minutes. Duration, please. Based on that, I should. What is my duration of the session? Is it 30 minutes?
Yes, sir, the time allotted is around 20 to 25 minutes.
Okay, fine. 20 to 25. Okay, so now it is, okay, 11, 12:30 I'll start. Fine?
Okay, sir.
Okay, great. Okay, so it's my great pleasure to be here to deliver a lecture. And so I'm so happy to Guljan, Dr. Guljan, inviting me, and Dr. Pooja as well, and the chairperson of this session. So without going further, I'll share my screen first and directly go to my session. Is my screen visible?
Yes, sir, it is visible.
Okay, great. Okay, so today, so I know you are hearing many other topics in different science, which include chemistry, physics, statistics, many things. And you mentioned about the conference is mostly about a sustainable development goal as well. My session is today is to see the topic I have given is interpreting with caution, understand the statistical misuse in medical research. As I'm working in medical field, I can say more about the medical statistics, how it is misusing in the medical field. I know it's misused in many other part of the world as well, but what is happening in the medical field today, I'm going to discuss here. Especially many in the public health, as you know, I'm working in public health department and professor of epidemiology and biostatistics as well. And we mentioned about the evidence. Many times we mentioned about the evidence. Coming to the evidence, most of the place we are utilizing statistics to find the evidence. Why we are using, where we are using. You can see, if we are trying to find a drug is better than the other one, what do? We do the experiment on the patients then we see the difference what you observed is effectiveness is significant or not. We used to apply some statistical method. While using the statistical method, think about the statistics what we have used is not the appropriate method. What is the result? The result will be wrong. So what is not happening? Evidence is not happening. So what I'm trying to say this lecture is the caution. Always when you use the statistics, very much you you have to double check that result before going for the publication part. Many places I know non-statisticians are doing statistics because many softwares are available to analyze the statistical data like SPSS. What they feel, if you click some of the keys, you will get the result. The result may be correct. But when you go to in detail what is the publication available in the literature, you can see many wrong things what you can see. Okay, so I'm going to say about why we use statistics. That's what I mentioned. So if you want to go for any evidence, any type of evidence, you need statistics. Without statistics, it's not possible to make any conclusion. Or we usually used to say, when you go to the physician, also used to say, the risk factor for the cardiovascular disease is the consumption of fat food or the consumption of tobacco or consumption of alcohol, something. All this, how we know these are the risk factors? With the help of statistics. If statistics is not there, it's not possible to say which are the things are risk factors, which are the thing protective factors, not possible to say. Always effectiveness of treatment. We have many different drugs are available. Whether which drug is better, again, we need the help of statistics. The outcome of the patient, how patients is surviving after getting a disease. And many places, it is important. Important statistics is playing a vital role as well. So this, so I'll go, how statistics is misinterpreting in the field of, in scientific field as well as the layman field. This you can see, this one of the article published in newspaper. This, you can see this published in Gulf News. Gulf News is actually one of the leading daily in the EA. The title of that article was Heart Disease on Rise Among Young Expats, says the study. Indian expats get high risk of compared to others. This is the study title, and they have given some writing as a text is there. Then they showed the picture as well. And what is written is you can see here they have included around 142 patients are referred to a cardiac laboratory from mid-June to I think. Among them, 66% are Indians, 62% are Indians. And then what they said, 74% are less than 55 years. So then they conclude that the conclusion what they made is you can see the coronary artery disease is more among Indian expatriates compared to others. And the age is very, they're getting the diagnosis is very younger age, maybe in 35 to 45 years. That's the conclusion. What do you think about this study? So this published in a leading newspaper, not scientific, not in the journal, but in the newspaper as well. But what do you think about this? Absolutely wrong, this conclusion. What they did actually, they have pooled 142 patients. This all, again, this study conducted one of the Indian hospital, Indian management hospital, I can say. So there, what is happening? The cardiac session is there. Patients are referring from other centers. Again, think about other centers. All other centers, those who are referring patient to this center is again from the Indian hospitals only, Indian management hospitals only. So what I am expecting more than 90% of the patients, those who are referring in that center should be Indians. What they observed only 66%. Do you think it's a high percentage? No. So this is a great bias here. So by the way, what is bias? Is a systematic error. So they made an error here. So this conclusion is wrong. Then what is their next conclusion? They put it's getting below the 55 years. Indian expatriates working in the EAA after 60 years, what they do? They go to their country or they go to India, right? So what is happening? Those who are diagnosed here, those who are here, they're working here is mostly below the 60 years only, or mostly below the 55 years only. So what we are expecting, that age only we can see there. So here, before making this type of conclusion, we have to be take the care about the things. So otherwise we are giving a wrong conclusion to the population. And, if this type of news are, in the community, they are worried about that this type of result. So what we do? We have to be very cautious about while giving this type of result in a media. So this one example. This I said about this. This is in a non-scientific media. So now coming to the media also, so scientific media, like many journals also, what you can see, this type of error possibilities you can see in many journals as well. You see, so I'm skipping all this slide now because we have only 25 minutes. So here, we'll see on example, we'll see and then go further. A researcher conducted a survey among 10 nurses using you know about Likert scale, right? Likert scale is a scale where we use a 5-point Likert scale, means we say 1 for strongly disagree, 2 for disagree, 3 for neutral, 4 for agree, 5 for strongly disagree, and so on. So here we can see what type of variable is this. The survey, what they use this 5-point Likert type scale about electronic health record improve patient care. So here, do you think you'll get a numeric here? No, they are getting only the qualitative answers from the qualitative yield they get. So what they usually what they do in journal, what you can see, they convert that into numerics. 1 for strongly disagree, 2 for disagree, and 3 for neutral, 4 for agree, 5 for disagree, and so on. So here in the numerical sense, what you can say, that is if you take 1, 2, 3, 4, and so, what you can see, the distance between 1 and 2 is always equal to distance between 2 and 3, and this is always equal to distance between 3 and 4 as well. But do you think the difference between strongly disagree and disagree is same as disagree and neutral is same as neutral and disagree and is same as agree to strongly agree? Not really. So if you take a mean, do you think it will get a correct answer? No. So what they did a mean. What they observed is mean is 3.2. So what is your conclusion from the study? So 3, if you see, is neutral. So what they are going to say is, the conclusion what they are going to say is, electronic health record improves the patient health. The population opinion is neutral. Why it is happening? Because we are taking the mean. So otherwise, again, another aspect is whether we will include the neutral or not. That's second aspect. Otherwise, also it's not a good way to analyze using the mean. So you know that in statistics, different central tendencies are there. Mean is there, median is there, mode is there, geometry means, harmonic mean. This type of other central tendencies are there. So what we should do, we should see which is most appropriate for a particular situation. Based on that, we have to use the statistics. We'll go for another example. You must have learned about, I know some of you are statistics students. There are also maybe PG or UG as well. But we know about the correlation. So we know that the correlation coefficient is a value always lies between -1 and +1. So you can see a study here. Study was conducted to find the relationship between salivary cotinine and the number of cigarettes used per day, and they observed the correlation coefficient of 0.4. And the others did the significant the testing of hypothesis. What they observed is a p-value less than 0.001. The conclusion you can see here, but the conclusion, there's a strong relation between the number of cigarette use and salivary cotinine. Do you think it's right? No. The conclusion is not based on the p-value. They made the conclusion based on the p-value. It's not based on the p-value. You should look into the correlation coefficient. The coefficient you have to see. Coefficient is 0.4. What does it mean? The relation is weak. So what is the p-value says? The weak correlation, what we observed is not due to chance, is real. The p-value less than which is not, the p-value is checking the observed difference is due to chance or it is real. So the conclusion is based on this, not based on this thing. But most of the time, many journals, what is happening? They look into the p-value and based on that, they used to conclude that thing. Now, so I'll move to the next slide. Another slide, I'll go. Okay, so because we have 10 more minutes. Okay, see here, another one is about the sample size. Another thing is about sample size. If you think about the statistics, always we used to calculate the sample size. If we increase the sample size, what will happen? Or decrease the sample size, what will happen? And what is the importance of appropriate sample size as well? You can see here, now we have, you know what is odds ratio, right? Odds ratio is the odds of exposure ratio, which will tell the chance of getting disease among the exposed group. For example, you are taking the the study between tobacco use and lung cancer, you got an odds ratio of 1.8. What does it mean? Those who are smokers, those who are exposed to tobacco, chance for getting disease is 1.8 times more likely getting the disease compared to those who are non-smokers. So odds ratio is giving how much likely to develop disease compared to those who are not exposed. Exposure means this particular example, what I said is tobacco use. So you can see here, no, maybe think about this study is about the use of maybe tobacco and stomach cancer. You can see 3 studies conducted. All 3 studies we got an odds ratio of 1.8. We can conclude that the likelihood of getting disease among the smokers, the stomach cancer among smokers is 1.8 times more compared to those who are not smokers, right? But we always used to calculate the confidence interval as well. What confidence interval says? Confidence interval says I said 95% confidence interval. Usually we used to calculate 94 or 99% confidence interval. Most of the time, what you can see 95% confidence interval because we take the p-value of 0.05, right? So what they observed, you can see here the confidence interval. The first one, the confidence is narrow. Second one, little more wide. Third one, you can see more wide as well. So what is happening here? Again, if the confidence interval is wide, what does it show? It shows dispersion is more. Means what? Is not reliable. So in dispersion, usually what we do, you measure the reliability of the thing. So here what you can see, study 3 observes the same odds ratio, but it's not that reliable because the odds ratio is very wide. What does it mean? Maybe one study will show the chance for getting disease is 1.1 times higher, but some other study may say the chance for getting disease is 23.5 times as well. So what you can say, so the range is from 1 to 24. Is it reliable? It is what we can say about that. Not rely on this particular study as well. Now think about the sample size misuse also you can see. So here, I conducted one study to see whether the alcohol consumption is related to esophageal cancer. Alcohol consumption is a cause for esophageal cancer. For that, what I did, I conducted case control study. The case control study I did 4 case control studies. You can see first one with the 500 sample, second with the 600, the next one with the 700, and the last one with the 800 sample as well. You can see here among the 500, what is happening? 125 with the disease, 375 with the no disease. Similarly, you can see the remaining as well. You can see the result here. What result you can see here now? So this is with respect to 400. I said, among them, controls are 300 and the cases are 100. Sorry, the previous example I said the 400 is not shown here. So I used with the 400, 300 control and 100 cases. Then I did an odds ratio. You can see the odds ratio what I observed is 1.48, right? Now I'll go down and see. Again, I calculate the confidence interval. You can see the odds ratio is 1.48 and I did the confidence interval is observed is 0.91 to 2.40. So you can see here exponential beta. The exponential beta is otherwise called odds ratio, odds of exposure ratio. You can see here the confidence interval what we observed is not significant. Here also you can see the confidence interval is the observed odds ratio is not statistically significant. This from the confidence interval also you can see this is not significant. Why it is not significant? Because the lower limit is less than, so value observed is less than 1 and the upper limit observed is more than 1 as well. Now, what I did, I increased the sample size. Instead of 400, I increased 500. What is happening now? As I mentioned, it is 375 control and 125 cases. Again, I got a value. Exponential beta is almost same. But what is happening here again? It's not significant because the value is more than 0.05. And the confidence interval also says it's not significant, right? Then what I did, I increased the sample size again. Instead of 500, I increased 600. What is happening now? Any change in the odds ratio? No change in the odds ratio. What is happening in this one? Is it significant? Not significant. What is happening here? Again, the confidence interval says it's not significant, right? So I increased up to 600. Now, what I did, I increased to 700. Sample size increased to 700 and controls right now 525 and cases 175 as well, right? But you can see same odds ratio 1.75. But what is happening now? Now it is significant. You can see here also the confidence interval also shows it is statistically significant, right? So what is happening here? The significance, is it the significant real significance? No, but I don't think it's a real significant because, the sample size increases, what happen, the chance for reducing the standard error, ultimately we'll get a significant level as well. So when you go for the meta-analysis also, we have to think about this aspect also. Again, I increase the sample size to 800, what is happening? No change to the one, what is that, exponential beta or odds ratio, but level of significance is reducing, what you can see. So if we increase the sample size, what will happen? The significant level will increase. Okay, now we'll go to another aspect also. So here, we want to find the effect of two drugs. I can say A and B. A and B, two drugs are there. We want to see whether which is better to reduce the fasting blood glucose level. For that, a clinician input 20 patients and 100 patients each group. Include 20 patients in each group and 100 patients in each group. You can see that the details here. The investigator A, he include those with the drug A, 20 patients he asked to take drug A, 20 patients to take drug B as well. And then what he did, he measured the fasting blood glucose level. After 3 months, I can say, observed is 124. Here what you can see is 115. So from this study, what is the conclusion? A is better or B is better? So I don't know whether you can you have a mic access, but I can say here, drug B is reduces more. So maybe you'll say this is better, but no. Whenever you want to make a conclusion, not only look into the mean, you should always look into the standard deviation as well. In the previous slide also, I mentioned about the importance of standard deviation. Standard deviation will see what is the reliability of the thing. So here what you can see, the standard deviation increases. What does it mean? The reliability of the result is decreasing. Even though the value is less, what is happening? Some patient reduction will be there, some patient reduction is not there. So that is what is called the reliability. So now we are confused here. So what we did, we go for a t-test, and the t-test says is not significant. Means what? We got a difference between 124 and 115. The difference is what is called effect size. This difference is what is called effect size. What I can say, effect size is almost 9. 9 unit difference is there, but still it is not significant, right? So the investigator B, what he did, he enrolled 100 patients in group A and 100 patients in group B as well. And again, he observed, we can see, here the mean value, what you can see here, compared to this, the difference is less. Effect size, what you can say is less only, but still he did the t-test, and what he observed is statistically significant. So what is here conclusion? Here, investigator B conclusion is that drug, B is better than A. But investigator A conclusion is what? There is no difference between A and B, which is right now confusion now, right? So here, if you see, here effect size is more here, but here effect size is less here. But still, what you say, second one is significant compared to the other one. So maybe what we do, before going to the study, we have to see how many minimum sample we need for the study. Based on that, we go and proceed with the studies. Now, okay, I'll go fast. I think I have 5 more minutes. Okay, so what we can do, so this type of errors you can see in many articles as well. So what we can do actually, so when we read this as statisticians, when you read the article, you read in the critical way. So what I did, you can see here, you can see a study, you can see here, the same title study as you can see here as well. So here maybe, you can see my name is here. Here my name is not there. So what is happening here? This is a error. This article, when I read this article, there are a lot of errors. I wrote to the author or the editor, and they published what are the errors in this article. So you can see that these are actually errors. One of the errors, what you can see here, they use a chi-square test. See here, many cell values with a 0. All the 0 value and 1 value, they did a chi-square test, means it's wrong. So they cannot do the chi-square test and make a conclusion like this. Now, see here also you can see the same thing. See, many things wrong in the published article. You'll see another article. You can see here again. This, we have in statistics parametric tests are available, non-parametric tests are available, right? So some cases, instead of using parametric, they used to go for non-parametric. Instead of using non-parametric, they go for parametric test as well. So this article, what you can see, they use the opposite way. You can again, you can see this all published article based on the errors. The second is, you can see the right side on what you can see is the error, what we wrote to the editor. The left on what you can see is original article. Here also you can see here, here also you can see this is published, a letter published from our side, the errors. right? This is the original article. Then you can see here again, this I'm going fast. Here also you can see this article, there are errors, we publish, we send a letter and they publish the error as well. So many, so we have many this type of letters editor there. This is another one, you can see another one here, then another one here. So I showed only few here and on here. This, this is in Lancet also. Lancet also we wrote a letter to the editor regarding some of the errors they put in there.
Yes, sir.
Yes.
अरे हम ऑलरेडी ज्वाइन है भाई आप हाँ
Hello.
हाँ
Hello.
हाँ
Hello. Sorry, so someone else. Okay, so you can see this is very recent. Only you can see American Journal of Cardiology also we have wrote a letter to the editor because there are also some. I have no time to point out all these errors. But so what I want to the takeaway is always before going to go, you have to if a statistician you are not a statistician, meet the statistician and see how to go about the study and how to make a decision on the particular analysis. You know that all of this type of studies, now whatever study you do, without statistics is not possible to say. So always collaborate with the statistician and do the analysis. So these are some of the references. I stop here. Thank you so much. So I put a word also here. You can see trust numbers, but question methods. Okay.
Thank you, Professor, for the nice talk. Indeed, a very useful one for all the budding researcher as well as the statistician. A number of students of PG classes must have been benefited a lot. If there are any questions, please put your question. Any question from any side? So I suppose none. Thank you, Professor Sridharan, for the nice talk. Indeed, it is a useful one. Thank you.
Thank you so much. Thank you so much. Thank you.
Thank you, sir, for your valuable presentation. Our next speaker is Professor Dr. Devdutt Chaturvedi, sir. Sir is a professor and head of chemistry and dean at the physical sciences at MGCU Motihari. With over 25 years of teaching and research experience, he has published more than 100 papers, filed 17 patents, and delivered 70 plus invited lectures worldwide. He is a recipient of many prestigious awards, including the Young Scientist Award, DST Fast Track Award, and the W. Malik Award 2024. Though he could not be physically present with us today, we have him joining virtually with us to deliver his presentation.
Hello. Are you getting my voice?
Devdutt sir, sorry for the inconvenience. We have a already scheduled session from US. The person is waiting since long, and there is a night. So I request you to please wait for your turn. And we are calling Dr. Bhaskar Thakur right now.
Oh, okay, okay.
Sir, please.
We have with us Dr. Bhaskar Thakur, sir, Assistant Professor at the UT Southwestern Medical Center, Texas. Sir is a faculty biostatistician at the UT Southwestern Medical Center, Texas, associated with the Departments of Family and Community Medicine, Emergency Medicine, Physical Medicine, and Rehabilitation. His research interests span epidemiology and biostatistics with a multidisciplinary approach, focusing on health disparities, social determinants of health, neuropsychiatric epidemiology, sleep health, cardiovascular risk factors, brain injury rehabilitation, health informatics, and implementation sciences. It is my honor to invite Dr. Bhaskar Thakur, sir, to deliver his presentation virtually.
Thank you. Am I audible to everyone?
Yes, sir, you are audible.
Thank you. Let me first thank you to the organizing committee for this invitation and this wonderful opportunity. I'm going to talk today, not very statistical, but one of the foundational work of our ongoing study, which we recently conducted and published, propensity score matching and mixed effect model for comparing cardiovascular disease prevalence after traumatic brain injury. We have here in United States traumatic brain injury model system, and we have compared that with the national control population utilizing nutritional examination and nutritional survey. And we compare the cardiovascular prevalence. We all know that the cardiovascular disease is a leading cause of death, not only in the United States, but globally. And the cardiovascular disease and its risk factor are associated with cognitive decline and dementia, not only in the general population, but also in the different comorbid conditioned population. So this is really important to identify this treatable and modifiable risk factor of cardiovascular disease in the person with traumatic brain injury. So our primary objective is to compare the prevalence of cardiovascular conditions in those individuals with moderate to severe traumatic brain injury and who were enrolled in the TBI model system to a propensity score matched community-based control cohort using the National Health and Nutrition Examination Survey database. So briefly, I would like to tell you that the TBI model system is an ongoing cohort system for the traumatic brain injury patient. And we included moderate to severe TBI patient. And these patients getting enrolled during the inpatient rehabilitation, and they were followed up at year 1, 2, and 5, and then after 5 years thereafter. And other than the clinical parameters, some self-reported questions on their health conditions have been asked similarly as those were asked in the National Health Survey, which is ENHANCE. So ENHANCE is the data from ENHANCE is collected through the random sample, and which is showing the general population of the United States, and it's a cross-sectional survey. And in this study, we included all those patients who has the age of 18 years and older. And the interview were conducted between January 2015 to March 2020. These were the variables which were considered in the propensity score matching, which including age, sex, race, ethnicity, body mass index, education, and smoking status. And we considered one-to-one matching criteria because we had the huge sample size. So 1:1 matching criteria we consider just to have a great balance between the TBI and control population. So what is propensity score matching? Usually in conventional method, we control the number of covariates to show the independent impact of the exposure or the treatment on the outcome. And propensity score matching is a method which nowadays replacing majority of the randomized control trial. Often randomized control trial is difficult to conduct, and then we need a lot of resources to conduct such trial. So if we have a good database, we can use propensity score matching, and the methodology is similar as we randomized as we adopted the randomized control trial. On the similar ground, the propensity score matching also balance all the covariates and make the two groups comparable. So we use in this method, we use a probit regression model in the PSM method. And we implemented one-to-one nearest neighborhood propensity score matching with a caliper distance of 0.01. And our primary outcome included hypertension, congestive heart failure, heart attack, stroke, and diabetes, which were measured as a binary variable. And we have also tested, after applying this propensity score matching, whether the covariates are well balanced between the two groups or not. So if you see this data based on this propensity score, which is in the second column, you can see in the first pair, for example, the propensity scores are very close to each other. And the first one is belonging to the control group and second one is belonging to the TBI group. And the propensity score is very close, 0.014 and 0.018 after applying that probit model within the PSM method. For the second pair, you can see that the propensity score is 0.033 in the control group, and also in the TBI, we have 0.033, which ensure that the propensity score in each pair of, in any particular pair of combination, if you will see, the propensity score are very close to each other, which looks like it's a balance. But can we judge the similarity based on just the propensity score? Our main goal is to see at the covariate level whether covariates are balanced or not. So in the subsequent slide, if you see here, we have this propensity score and then the pair ID and all those variables which we used in the PSM probit model. And if you see the first pair, the first two observations, you can see the propensity score are very close to each other. But if you see the age in the control group, it is 74, and in the TBI group, it is around 64. So huge difference in BMI, and their gender is completely different, and their race is completely different. Although they are non-Hispanic, their education were again different. So a lot of parameters are different. In the second pair, you can see few parameters are matching and few are not matching. So our goal is to by applying this propensity score matching is to see that how these covariates are well balanced between the two groups. So we do not need further to control in the second stage of method of analysis, when our goal is to see the linkages between how TBI is impacting cardiovascular condition. So in individual pair, we can see this difference, but our goal is to, on an average, this mean age or mean BMI or the level of these categorical variables are equally balanced. It should be equally balanced between control and TBI population. So if you see this graph, the upper panel, forget about the color, but the upper panel is showing this is a treated group, which is a TBI group, and the lower panel is untreated, which is a control group. If you see the upper panel and lower panel, and this is prior to matching, and it looks like this is not a perfect matched, right? However, based on the propensity score, the upper panel has been subdivided between two different colors. And if you see the red color, this is actually treated on support. That the meaning that these are the folks which are somehow comparable with the control unit, which is like the bottom part. And the green one is the treated op support. So these are the treated unit whose propensity score do not overlap with any control unit. So this is not in the matching set of data. So this will be discarded later on in the later stage. So if you see, and this is the story of the prior to matching. If you see here, prior to matching, where our control size were 15685, the TBI sample size were 11063. And if you will look at each of these, the factor which we utilize to model the propensity score probit model, you see that other than the education level, everything are not significant, meaning that they are not well balanced between the control group and TBI group. In this slide, we saw that how the treated on support group is has some promising kind of things with the control group, and so we use here. And this is the scenario of after matching. So you can see that how this looks like well balanced, and you can see by this picture, like you can imagine like how this is very close to the ideal situation of a randomized controlled trial. So this method is really good rather than controlling the list of covariates in the model. So better is to do this propensity score matching, balance the group, and then just see the impact of your exposure or treatment under consideration. This is another method of standardized mean difference, which is often considered as a bias in propensity score matched analysis. And you can see, I did not bring the colorful graph here, but you can see here that solid bullet dot and then the cross sign, and the cross sign is very close to the null vertical line, which is a reference line, which shows that the bias is almost zero. And this cross is showing about the matched cohort. And the bullet line, solid bullet point is showing that about the unmatched cohort. And you can see that in unmatched cohort, how much this is far away from the reference line, indicating that huge possibility of the bias in the unmatched cohort. And this is the kernel density you can see on propensity score. And you can see that how our matched sample are truly representative, and which also emphasizing here that all the covariates are well balanced. And now at the covariate level, if you will see, all these variables, including age, gender, body mass index, different race, ethnicity, educational status, and smoking status are well balanced. If you see, since it is 1-to-1 matching, and with a caliper distance of 1, they have, based on the propensity score, they have chosen, the model has chosen the closest values. And since it is 1-to-1 matching, so you can see the sample size is similar in control group and TBI group from the larger sample size of control and TBI. And the p-value is indicating that this is not significant. Also, at the estimate level, if you will see, pretty much the percentage distribution are similar across the control and TBI population, which ensure that the matching is perfect. Now, the second stage was how to handle this matched data, and there are various recommendations to analyze this data. And there are lots of controversies is going on that this is not even you are matching. You are matching, and you are going towards the 100% matching sample, but still those are not the biologically same patient, and there could be a lot of heterogeneity among the paired of observation from control group and TBI group, what I have considered here. So people, a lot of different thoughts of school and people are using independent t-test or just a logistic regression and treating them as an independent depending upon the nature of the outcome variable. But also the other group who consider as a matched pair, and then they use if the continuous variable pair t-test, or if it is categorical, then well-known model is a conditional logistic, which we use in the matched pair binary outcome setting. So it has been recommended to analyze the PSM data in the same way as we do the randomized control trial. And so if you go to the randomized control trial methodology, you will see that most of the time, if the outcome variable is binary or some incidence of some condition or something which you are going to observe, most of the time you use a mixed effect model. So with the same ideology captured from the randomized control trial methodology, we adopted in the matched cohort setting, which is not a drug trial, but here our goal is to see how the TBI population is impacting to the different cardiovascular disease. So we used the mixed effect model, which considered the matched pair as a random effect. And this could be an alternative methods. There are not lots of paper on this, but people have published. There are 3 or 4 meaningful articles on utilizing mixed effect model after propensity score matched data. So I will not go details on this methodology on the mixed effect model and how what is the strength point and how this could be better alternative as compared to the conventional conditional logistic regression model. And this is how our population has been like the flow chart of the patients coming from the TBI model system database and the enhanced database, and based on certain exclusion criteria, we had finally 11,000 in the TBI population and 15,000 in the enhanced population. And then after utilizing the PSM analysis, we had 1-to-1 matched sample size, which is 4,619 in each of this group. This is prior to matching. We have already seen that how those were not balanced with each other, and after matching, these covariates are well balanced. And here is the result in the prevalence. So especially if you see the hypertension and then stroke and diabetes, the prevalence of these cardiovascular disease and risk factors are elevated in the moderate to severe traumatic brain injury patient as compared to community dwelling cohort. However, the heart failure and heart attack looks like more prevalent in the general population compared to the TBI population. When we run our mixed effect model, we found that the hypertension and stroke and diabetes, as we have seen in the previous table, prevalence was elevated in the TBI population. So similarly, in the odds ratio also, we found here that the TBI population are more likely to have the hypertension, stroke, and diabetes with so-and-so odds ratio with 95% confidence interval here. And the results is exactly matching with the previous table for the congestive heart failure and heart attack. These two conditions, TBI, are less likely to have these two conditions. And then our goal was to conduct a kind of sensitivity analysis. We wanted to make sure that the result is robust across the different stratifications. So we conducted the same analysis in the age group of less than equal to 50 years and greater than equal to 50 years. And then the another stratifications we did based on the follow-up criteria in the TBI model system cohort, which is less than 5 years of follow-up and more than equal to 5 years of follow-up. Certainly, this follow-up is not available in the enhanced, which is community dwelling cross-sectional data. but this was a clinical collaborator call to conduct this follow-up best stratification as they came on this decision theoretically driven, and the literature also says that the scenario could be different in the lower follow-up and the higher follow-up. So, but we found that in each of these stratification, our TBI is more likely to have hypertension, stroke, and diabetes pretty much everywhere. Slightly, if you can see, the 95% CI is the lower side for diabetes when where the follow-up is greater than 5 years. But still, this will be considerable as a significant because the confidence interval is very precise and the lower limit is very close to 1. And nowadays, also like in a statistical practice now, people have been advocating about the not 100% relying on the p-value. So we need to see the 95% confidence interval, how reliable the estimate is and how it is precise. So in addition to that finding, we also found that in the lower follow-up, the TBI population are more likely to have the congestive heart failure.
Hello, Dr. Bhaskar.
Yes, sir.
Kindly complete your talk ASAP because other presentations are also due. Right?
Oh, sure. Sorry about the delay. So I'm only in the conclusion slide. So in conclusion, so compared to the control cohort, individuals with TBI are more likely to have the hypertension and stroke, and less likely to have the MI and CHF. So with this conclusion, I am stopping my slide here and would be happy to answer if you have a few questions. I understand that we are sorting out of time. Thank you.
Thank you, Dr. Bhaskar. Indeed, a nice talk. So floor is open for the questions. Any question from any side, offline or online participants? Yes, please. Any question? Online participants can type their questions in the chat box so we can take those questions if there are any. So I suppose there is none. So thanks, Dr. Bhaskar, for the session, and thanks for the talk. Thank you.
Thank you, sir. Thank you for this wonderful opportunity. Thank you.
Thank you, sir. Now, our next speaker is Dr. Akhilesh Kumar Pandey, sir. Sir is an experienced biostatistician with expertise in clinical trials, EHR analysis, and population-based data research. He is skilled in developing statistical analysis plans, managing SDTM, and applying evidence-based statistical methods. He has strong experience in quantitative epidemiological studies and teaching biostatistics, epidemiology, and research methods. Dedicated to advancing healthcare, he actively supports researchers and clinicians with impactful statistical insights. It is my honor to invite Dr. Akhilesh Kumar Pandey, sir, to deliver his presentation virtually.
Thank you very much. I'm audible?
Yes, sir, you are audible.
Yes. Okay. Thank you for giving this opportunity to discuss this topic this conference. So I just wanted to give general overview of this mobile health. So topic is from smartphone to smart health, leveraging mHealth apps and wearable devices in public health research. Okay. So I will discuss what are the application in different research, what are the importance, and few studies which is going on and my experiences I will share with participants. So here, what is mHealth? So mHealth, also called as mobile health, refers to the use of mobile devices and wireless technologies such as smartphones, tablets, wearables, and mobile applications to support and improve healthcare delivery, disease prevalence, and health research. And key elements of mHealth are mobile apps for tracking health, like diabetes, blood pressure, fitness, diet, variables like smartwatches, fitness trackers, and continuous glucose monitoring, and telemedicine platform that connects patients and provides remotely. And also nowadays, SMS and notifications are very important for tracking patients and reminding dates and vaccination and all that for health education also. So why it is important? It enables real-time continuous data collection and also expands access to healthcare, even remote or underserved areas, promotes patient engagement and self-management. It provides researchers with large-scale, high-frequency health data. So the growing role of digital health. So we are in the era of digital in our country also. More than 80% have a smartphone now, and more than 1 billion wearables devices are there. And also it is integrated with electronic health records. So now it is easy to collect data from these wearable devices and from mHealth. So what are the applications in public health? So in chronic disease management, infectious disease surveillance, mental health monitoring, maternal and child health programs, all these can be covered through this mobile health or mHealth device. Also, we can capture digital biomarkers related to physiological like heart rate, oxygen saturation, glucose levels, and behavioral biomarkers like how many steps in a day and sleeping habits or duration, and environmental biomarkers like air quality of particular area or geolocations. Benefits for research of this mHealth or applications. So we can collect real-time continuous monitoring data, large-scale reach of the applications, and cost-effective, which is very important. Sometimes we are not able to conduct large level studies due to cost things. So it will help in reducing the cost and improve patient engagement. Also, nowadays it is easy to use smartphones and applications, so it will be interactive and very engaging for the participants. For case studies like diabetes, we can use continuous CGM like glucose monitoring devices. For cardiovascular risk, wearable ECG, and for smoking cessation apps for case studies can help. The statistical and methodological challenges. So we have high frequency time series data through the mHealth or health devices or applications. Missing data or dropouts possible because sometimes if it is not collected or not signed in, those problems are there. So device standardization issue is also there if applications are not the same version or sometimes technical error, those things are there. Validity concern. So validity also a concern for from these devices. Biostatistical approaches. So longitudinal models, we can have data with this kind of approach. Mixed effect models, if we plan, we can collect data through these apps and variables. Time series forecasting is very helpful for this kind of data. And machine learning applications, if we plan, we can use this mHealth. So one ongoing CGM study experience, which I will share today in our organization, which has a title Glycemic Effect of Food Among Diverse Indian Americans Community in the United States, Insights from the Continuous Glucose Monitoring. So here we are using this CGM device to collect glucose data from 51 Indian Americans, which are from different states, five different states like Punjab, Rajasthan, Bihar, South India, and Madhya Pradesh. So from different regions. So we want to just compare what are the different diet patterns affecting the glucose levels or spikes. So using 14-day CGM sensor as lab test. So before that CGM device, we have collected blood samples to have a lab test, and then according to the inclusion and exclusion criteria, we select participants and then monitor for 14 days. And then we discover that there are differences in how individuals and regional food traditions affect blood sugar spikes. So sometimes food habits are very important for glucose levels or spikes. So in North and South, food is different. So it differentiates what spike or what time of the spike we can capture with the CGM devices. Fasting insulin and TYZ index track early sign of insulin resistance better than HbA1c. So we use HbA1c for this insulin resistance, but we are now using the TIG index, triglyceride index, for forecasting about the fasting insulin for insulin resistance, and we are deciding the pre-diabetic and normal. So HbA1c often miss early risks, showing why real-time monitoring add value. So if you have a real-time monitoring, so we can use other tools for deciding or a risk factor of developing diabetes. Why this matters? Indian Americans and many immigrant communities carry unique cultural and dietary patterns. Understanding these nuances help us design personalized, culturally sensitive prevention strategies. So now we are excited about the potential of CGM and simple lab markers to make early detection and precision nutrition and reality. So we are planning second phase of this study, where we will include more subjects and pre and post kind of lab data, blood samples to and also providing some intervention to change the glucose level or spikes, to see what is the effect of intervention like physical activity or food or diet pattern. So this will be the second phase. In first phase, just we have given at baseline taken blood sample and then CGM device for 14 days. We have observed the glucose patterns and spikes, and according to that data, we are now planning in second phase to have intervention and pre and post lab data collection. So we will see what we will get the results. Another study which was done in coastal Karnataka when I was in Manipal University. So one of my PhD student, I was the subject expert at that time. He has used this mHealth application for developing a mHealth application for hypertension monitoring. And the third version of that protocol is published. So this is a protocol only. Now he is doing a second phase of the study. So I will just discuss what is the aim of that study. To develop and evaluate a customized, user-friendly mHealth app to improve self-care, knowledge, and health outcomes in hypertensive patients. So he planned to develop a new app-based hypertension monitoring. So in that, there are three phases. So in first phase, 12-month qualitative research to find out the background information. And in phase two, 12 months app development where IT people were involved in that. And in third phase, full-fledged RCT for 18 months, having 12 villages and 118 participants. So he's now in third phase. So we will see what will be the results. And in second phase, there were challenges to develop a new app, but now it is developed. And in third phase, he can collect data related to hypertension monitoring. So what we are expecting from that study, if effective, the mHealth app will improve patient knowledge and self-care, enhance hypertension management, offer a scalable community level tool across India. So that we are expecting. And also some ethical and equity considerations are required for with mHealth devices and apps. Privacy and data security is one issue. We should look into that. Equity gaps, urban and rural reach of this kind of technology, and algorithmic bias. Also, sometimes systematic error can make a difference in the result. So informed consent in digital studies are also important. Sometimes people don't understand the informed consent, and if it is digitally taken, so it is not taken seriously. So that we should address. Policy and implementation aspects. So role in health system, we have integration with national program. We can integrate this mHealth program in national programs and regulatory frameworks, contribution to SDG goals. Which in future directions, we can
Thank you, Dr. Pandey, for the session. And you have touched the very basic aspect of the research. Hopefully that will be useful. Now the questions are invited from offline as well as online participants, if there are any.
relevant
You
and
can ask
important.
or you can type your question on the chat box. Any question?
Yeah, I have one question.
Yes, please.
Yeah, hi, Akhilesh sir. I just want to understand from your perspective that you said that you will be using triglyceride with insulin for the insulin resistance algorithm. So, is this being tested against the OGTT, like the oral glucose tolerance test, because that's a gold standard, and I also feel that there will be a high variability in triglyceride. So, how would you plan to cater that the variation between different longitudinal visits?
So we already have both things. As we can see, also we have collected blood and tested, and parallelly we have triglyceride also, and with standardized cutoffs for TIG index, we are using that and comparing those results with HbA1c. So we are not developing any cutoffs or anything for already which is standardized. We are using that.
Okay, so you are using OGTT, that
Yeah,
means.
yes.
Okay, okay. And the variation part, how is going to be handled in the triglycerides?
Whatever variation, we are not giving any intervention. So whatever variations are there, we will observe that and consider it. And in phase 2, we can consider that.
Okay, yeah.
To handle. So here, this is an observational study.
Okay, look forward to for your phase 2 results. Thank you.
Yes. Thank you.
Yes, any other question? So I suppose none. Thanks, Dr. Akhilesh, for the nice session. Thank you very much.
Thank you for organizer to inviting me for this.
Thank you, sir, for your valuable presentation. Now, with great honor, I would like to invite Professor Dr. Devdutt Chaturvedi, sir, to deliver his presentation virtually.
Hello?
Yes, sir, you are audible.
Okay. So can I start it? Yeah?
Yes, sir.
Yeah, okay. My slides are visible?
Yes, sir.
Okay. So, thank you very much. Actually, first I would like to thank our colleagues, organizers, because Amity University is my alma mater. Earlier I was in Amity University Lucknow campus. And all are my colleagues, specifically Dr. Sangeeta Bajpayee and Dr. Pooja Srivastav, Dr. Gunjan Singh. These are all are my colleagues. So I am very happy to deliver a talk in our department, I can say, our earlier department. And I am very much thankful to especially Dr. Sangeeta Bajpayee, who has kind enough to invite me for this delivering this talk. And the topic of the today's talk is versatility of carbon dioxide. That's renewable applications and synthetic explorations. And the choice of this topic is only because of my work. Particularly, I have been working in this area from last 2-3 decades. And I have developed several chemistry on the chemistry of carbon dioxide. Therefore, I decided to talk on this particular topic. And carbon dioxide have also been used as a in recent years many renewable applications have been emerged that I will be focusing on those applications particularly. And you see here, uh, actually before going my talk, actually I would like to first mention the title of the conference is very much good. I can say very excellent. Because the role of statistical techniques in the development of science and technology nowadays they play very important role. And without statistical knowledge, one cannot analyze the proper data. That's why these statistical techniques are very important in science, in various areas of science and technology, such as in the various areas of chemistry, various areas of physics, various areas of mathematics, various areas of biotechnology, medicines, and botany, zoology, and engineering. These are the major areas which I have covered. And because the theme of the conference is on statistical techniques. So my concern was that without statistics techniques, these one cannot study the data. And in any of area of the science or arts, I can say also. So you see, keeping that view in mind, we because disposal is 3.4%, transportation fuels is major, is 14%, to the agriculture byproducts is 12.5%. So this is the statistical graph indicating the emission of carbon dioxide. So you see the projected growth in carbon dioxide emissions by 2040. You see here by the carbon dioxide emissions as years are increasing, the rate of carbon dioxide production is increasing. And this carbon dioxide is a greenhouse gases. So this is very important to eliminate carbon dioxide from the environment. So you see here, these are the various statistical graphs. Actually, we have initially we have started because the theme of the conference is statistical techniques. So keeping that view in the mind, we have projected the various graphs, the statistical graph on particularly carbon dioxide production in the environment. You see here the rate of carbon dioxide increasing. You see here a scaling curve is a very famous graph, and where you see here in this the projection that the carbon dioxide increasing as years are increasing. So these are the various graphs you see. In every graph, the concentrations of carbon dioxide is increasing, and so carbon dioxide is very harmful gas. It's also carbon dioxide production is also takes place through the carbon cycle. Through the various means, various processes you see from the plants. Carbon dioxide is also a source of photosynthesis. So now come to my point. This production of carbon dioxide from the various sources, that is a major cause of environmental pollution. And you see here, like carbon dioxide through the natural gases, through respiration of animals, through burning of organic materials, through nuclear explosions. So these are the various, base, various sources through which generation of carbon dioxide occurs in the environment, causes the environmental pollution. You see here the major consequences of what are the major consequences of carbon dioxide. That major consequence of the carbon dioxide you see here is one of the greenhouse gases. So it's a global warming occurs. And you see here the carbon dioxide is greenhouse gases causes global warming in the environment and thus results climate change. The warming of the Earth's climate is indisputable, and it is also estimated that most of the increase in the global temperature since mid of 20th century is due to the increase of greenhouse gases resulting from the human activities. Therefore, it is important to transform this carbon dioxide into value-added products, a valuable product which will balance our environment in many ways. So, you see here, the carbon dioxide actually exists in the three forms. One is gaseous carbon dioxide present in our environment. Other one is electrochemical carbon dioxide, can be generated in electrochemical ways. And another is supercritical carbon dioxide, that is solid carbon dioxide. So these are the different form of the carbon dioxide. So chemistry has been done by these three, using three carbon dioxide forms. So all these mentioned carbon dioxide has been used in the generation of value-added products. So you see here the carbon dioxide is source of. In recent years, it has also been observed from the various reported reports that carbon dioxide has been used as a renewable source of energy, because this carbon dioxide has been used as a generation of oxygen and electricity, nanomaterials like cement and fertilizers, carbon nanofibers, fuels, and plastics and other polymer products. Carbon dioxide is a major source, and in organic synthesis, carbon dioxide has been used as a different kind of generation of further synthesis of various kind of compounds. So being what are the advantages of carbon dioxide is a renewable energy, that is little to no global warming if use of the carbon dioxide, improved public health and environmental quality, and a vast and inexhaustible energy supply. And because of this, a more reliable and resilient energy systems and stable energy prices, and also involvement of carbon dioxide work may increase the job and economic benefits. So you see here the carbon dioxide in organic synthesis. Being an organic, basically I'm an organic chemist. So being an organic chemist, chemistry perspective, carbon dioxide has been used extensively in the synthesis of various kind of molecules, and it is a cheap and safe alternative uh, for like harmful reagents such as phosgene and carbon monoxide. Synthetic solutions implying carbon dioxide is various forms such as gaseous, electrochemical, and supercritical carbon dioxide have been takes place. You see here, carbon dioxide have been in a carbon dioxide have been used in various kind of synthetic molecules such as carbamates. We have also synthesized this carbamate, carbonate, substituted alcohols, amides. So these are the various the important molecules which has been generated through the carbon dioxide. What we have done in our work, carbon dioxide, you see here, like we have synthesized carbamate, SS dialkyl diethylcarbonate, carbonates, acyl thiocarbamate, carbazate, and substituted ureas. So now why we have what are carbamates? Carbamates are the stable class of the compound derived from the unstable carbamic acid by the substitution of amino and sterins. When this linkage is present in the cyclic system, then it is known as cyclic carbamate. And these compound, what's the reason of synthesizing carbamate? These are, have potential molecules in drug discovery. So keeping that, they have many other applications you see here is useful synthon, and in agrochemicals they have used it, So therefore, we here in drug discovery, carbamates plays important role. By it has been realized from the various reports that by incorporating this carbamate linkage into molecules may lead to manifold biological activities. You see here the carbamate increases in the Taxol. Here also you see an antibacterial drug wearing cyclic carbamate. So many biologically potent drug and molecules have carbamate, and we have already covered this book chapter earlier, where we have covered that the role of organic carbamate in anti-cancer drug design. You see here where we covered that by incorporating carbamate into the biologically active molecule may lead manifold biological activities. So since carbamate is a polar linkage and it can interact with the receptors of the proteins. So it is so carbamate is so therefore this carbamate is that can increase the bioavailability and in the biological system of that particular molecule. Therefore, these carbamates are very active. So on coming on the chemistry points, these are the various methods which we have developed. But just the concept behind we have taken here is, you see here, we have used amine with carbon dioxide, generated the monoalkyl ammonium alkyl carbamate ion. And in presence of this alkylating agent, you see here, this O minus of this will attack on this electrophilic carbon of alkylating agent will lead to the formation of carbamate. And the reactivity of this particular ion depend upon the nucleophility of this particular ion. And the nucleophility of this system can be increased by different kind of basic catalyst. And we have studied several kind of catalysts we have used, like benzyl trimethyl ammonium hydroxide, TBI, tetrabutyl ammonium iodide, tetrabutyl ammonium bromide, tetrabutyl ammonium hydrogen sulfate, carbonates, different kind of catalysts we have used here, and we found that Titan B is found to be the best catalyst in achieving the high yield of the carbamates. So this is another method for the synthesis of carbamates. You see here the one reagent, Vishnu reagent we have used here. Vishnu reagent is the mixture of triphenyl phosphine and diethyl dicarboxylate, and it has been used for, we have used this particular reagent for the synthesis of various kind of molecules like carbamates, xanthase, diethyl carbonate. So different kind of molecules we have synthesized here. You see here first reaction that using various kind of primary, secondary, and tertiary alcohols, using various kind of amines, using this is the Mishnobu reagent, using carbon dioxide in 90 degrees centigrade, achieve the formation of the carbamate of the various primary, secondary alcohols. This is the overall mechanism wherein you can see here that the unstable carbonic acid form 1 react with the Mishnobu ion form 2, they form the ion 3, which upon reaction with alcohol lead to the electronic rearrangement to form the carbamate. So keeping that concept in mind, that this is another concept using the earlier concept where we have synthesized the carbamate from the alkyl halide using amine, using Titan VCO2 approach. So this is another approach for the synthesis of carbamate using alcoholic tosylate as alkylating agent. The earlier concept we have used here where they are alcoholic tosylate as alkylating agent. Titan B and CO2 system we have used here, and we have generated a series of carbamate directly from alcoholic tosylate. This is another synthesis by the synthesis of dialkyl carbonate using
Professor Chaturvedi.
Yes.
I request because we are already running late as per the schedule. So kindly try to complete your talk ASAP.
Just wait for 2-3 minutes. It will be completed. Okay. So these are this carbonate and these are synthesis of carbonate here, starting from various thiols. This is another synthesis by the synthesis of this SS dialkyl diethylcarbonate using carbon dioxide, and this is another synthesis by the synthesis of carbazate using this kind of substitute hydrogens using this Titan CO2 system. And this is another synthesis by synthesis of carbazate using Mishnobu with this Titan CO2 system. And this is another synthesis by the synthesis of carbazate using Mishnobu reagent. So this is the various work using carbon dioxide. You see here, the urea is also produced by Mishnobu reagent carbon dioxide system. And so this is all about my work. And again, I would like to thank organizing team of the conference. Thank you very much for your kind attention.
Thank you, Professor Chaturvedi, for the session, for the talk. If if there is any question, kindly ask. Offline or online participants, any question? Any question from the student side too? Because the lecture covered the fundamental part also.
Yeah.
So I suppose there is none. So thanks, Professor Chaturvedi, for the session. Thank you very much.
Yeah. Thank you very much. Thank you very much.
Thank you, sir. Now I would like to request our session chair, Professor Dr. Masood Hussain Siddiqui, sir, to kindly sum up the session.
So this session is actually related to statistical technique in advancing sustainable development goals. Here we have 4 sessions, 3 exclusively dedicated to the statistics and the machine learning part. And 1 is related to the chemistry, but all the speakers have very well connected the spirit of the interdisciplinary research. The various domains has been touched upon, including the biostatistics as well as the disease detection apps are also been covered, as well as a well detailed approach of the chemistry and the related analysis they have already been covered in a good manner in the session. So thanks to all the speakers, all the esteemed speaker for the session. Thank you very much.
Thank you, sir. I would request our HOI ma'am of ASA's department, along with Dr. Sangeeta Bajpai ma'am and Dr. Gunjan Singh ma'am, to kindly felicitate Professor Dr. Masood Hussain Siddiqui, sir. Also, I would like Pooja Srivastav ma'am to join them. Thank you, everyone. This concludes the morning session of our conference. We will now proceed for the lunch break. The dignitaries can have their lunch in front of the MPH, and the participants and coordinators are requested to move to the back of the auditorium for the lunch. Also, everyone is requested to report upstairs for the group photograph. We will resume the next session at 2:15.
Good afternoon, everyone.
Good afternoon. Outside. Hello. 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 Hello, guys. Geet. Pathvi. Pathvi. Geet.
Miss Anukriti Mishra is present? No. Miss Manali Tripathi? Miss Anubha Saxena? Miss Nazia Arif? Mr. Pankaj Gautam? Mr. Aditya Singh? Miss Swarnlata Tarai? Mr. Sashikant Tiwari? Mr. Ranjan Kushwaha. To understand women's health is to strengthen the health of an entire society. Ms. Swarnlata Tarai would present her important study on disease trends in women.
कहाँ शेयर करना पड़ेगा?
कहाँ से शेयर करना?
Respected judges, fellow participants, good afternoon, everyone. My name is Sonalata Tarai from Department of Statistics, Banaras Hindu University, Varanasi. Today, I will be going to present research paper titled "A Bayesian Framework for Understanding Non-Communicable Disease Trends in Women in India." Basically, my research work is based on Bayesian modeling, formulation, and application in health data. Okay. Yeah. Thank you. Hello. These are my contents. A disease is a problem in the body that stops it working working normally. It can cause pain, symptoms, or harm. It can be broadly categorized into communicable and non-communicable based on how they spread and their causes. Basically, communicable diseases are those are caused by infectious agents like bacteria, virus, fungi, or parasites, and can spread from person to person or animals or in the environment. These are the examples of non-communicable disease. Communicable disease. Non-communicable diseases are those are caused by infection cannot spread between people. They often result from genetics, lifestyle, or environmental factors. The examples of the non-communicable diseases are diabetes, heart disease, cancer, asthma, thyroid, hypertension, and kidney disorder. According to WHO report, non-communicable diseases kill 41 people each year, equivalent to 71% of all deaths globally. A growing body of literature suggests that women are more likely to experience the co-occurrence of behavioral risk factors, thus increasing the risk of NCDs among women and in the future generation. In this study, we empirically assess the association of behavioral factors such as alcohol consumption, tobacco use, and a variety of socio-economic characteristics with prevalence of NCDs in adult women through a Bayesian perspective. For the study, we consider data from National Family Health Survey. It is fifth in the NFHS series and conducted during 2019 to 20. It provides information on population health and nutrition of people in India and each state and union territory of the country. Outcome variables are considered is binary in nature, indicating presence of NCD recorded as occurred or not. The outcome variable encompassing the NCDs were hypertension, diabetic, asthma, heart disease, and cancer. If the respondent had any of the aforementioned cases, they fall in the NCD present category. Explanatory variables are the explanatory variables were selected on the basis of extensive literature review. The variables were divided into three sections that are behavioral, individual, and household characteristics. Behavioral characteristics are smoke tobacco, chew tobacco, or alcohol consumption. Individual characteristics are age, educational status, working status, marital status, media exposure, and BMI. Those are household characteristics. Our interest mostly lies in knowing the individual impact of these factors and of course the impact of interaction of these factors on the occurrence of NCD. These are my model formulation. To begin with, let us assume D is the disease status or n independent observation from a Bernoulli distribution with probability mass function given in equation 1, where PI probability of is the mean of Bernoulli distribution. In the logistic regression model, we have a logistic function that establishes the relationship between mean PI and other predictors. These are given in equation number 2, where beta naught is the intercept and beta j are the regression coefficient and xij are the predictors. Using equation 2, you can easily observe that PI is the likelihood function given in equation number 4. Before proceeding the next step, we need to standardize the predictors since they may not all on the same scale. For this purpose, we follow the method suggested by Gelman. The Bayesian modeling requires defining the prior distribution for the various regression coefficient involved in the model. We set Cauchy distribution with scale 10 to the regression intercept and the same Cauchy distribution with the scale 2.5 to the other coefficient. These are given in equation number 5. And lambda j is the scale parameter. The joint posterior up to proportionality can be obtained by combining equation number 4 and 5 by Bayes theorem. This can be written up to proportionality in equation number 6. Evidently, the posterior given in above equation does not exist in closed form, resulting up to adopt MCMC based techniques to get the posterior samples. Thus, Metropolis algorithm to obtain samples of all regression coefficient is proposed. As mentioned earlier, we will now proceed with the numerical illustration using data from NFHS 5. The data set containing information on 7,24,105 subjects. We have several covariates, information such as age, educational status, working status, smoke tobacco, alcohol consumption. The covariates of age of a woman is divided into 3 segments, where 0 represents the age for 15 to 24 groups, 1 for 25 to 34, and 2 for 35 to 49. Similarly, other covariates are also divided into various segments according to the study. The form of logistic regression model can be used to define the likelihood function. The posterior corresponding to equation 6 can then be rewritten using this likelihood function and the prior as in equation number 5. The Metropolis algorithm was applied on this posterior and the convergence monitoring was done on the basis of ergodic average. The initial values of running the chain was based on ML estimation. Once the convergence was assessed, we took equally spaced outcomes to form a posterior sample of 1000. The posterior means of the model coefficients were estimated using a sample of size 1000. The most efficient results are presented in the table below. These are my beta coefficient. Based on the above table, we can easily conclude that the smoking tobacco and have an important role in the occurrence of NCD. It can be seen that women who are overweight or obese were more likely to have NCD. In addition, increasing age, being married or divorced or separated or widowed were associated with a higher risk of NCD among women of reproductive age. Conclusion, this study concludes that the prevalence of NCD in women are still a major problem in India according to the NFHS 5 and is majorly affecting by the behavioral individual as well as the household characteristics. Some aspects of the considered research problem are still on process. These are my references. यार थैंक यू स्लाइड्स कहाँ गया थैंक यू स्लाइड्स नहीं
Can you answer that question?
Yes, ma'am. I considered urban or rural, but the result of these two indicators are not much efficient. So that I here I only shows the result of the most efficient result. I only show this.
Okay,
result.
that is understood. But since you have mostly considered lifestyle changes and all those things also in this,
Yes,
so
ma'am.
these are quite different in rural and urban areas. So
Yes, ma'am.
if it is not, if it is not coming properly, then you need to see that is there some kind of overfitting or underfitting or some kind of like error you are making, because
Yes,
it
ma'am.
is a major factor. Whatever things you have, that rural population generally is into tobacco and all.
Yes,
Okay,
ma'am.
urban women may be having stress and other things.
Yes,
Okay,
ma'am.
so this needs to be taken care of.
Thank you, ma'am.
Fine, thank you.
From my side,
Okay,
Beta,
ma'am.
you can draw some graphs for comparing the result for the urban and rural areas, right?
Okay, ma'am.
It will be more emphasize your paper
Okay, ma'am.
wherever you send, right? Thank you.
Thank you, ma'am.
Thank you, Ms. Swarnlata, for your presentation. The goal is to turn data into information and information into insight. Good afternoon, everyone. It is my privilege and honor to begin this session by extending a warm welcome to our esteemed dignitaries and all the participants who have joined us for this gathering. We have with us our session judge, Dr. Sumita Mishra ma'am, who is a professor at Amity University, Lucknow campus, with over 20 years of expertise in electronics, communication, machine learning, and wireless system, a fellow of the IETE and the senior member of IEEE. Ma'am has published extensively and holds patents and contributed globally through research and conferences. Also, we have with us Professor Dr. Nimisha Mishra ma'am, Faculty of Mathematics at the Amity University, Lucknow campus. With 21 years of teaching and research experience, she has published 20 research papers, 5 book chapters, guided PhD scholars and projects, and organized several national and international events. This afternoon, as we continue our journey of knowledge sharing, let us remind ourselves that the strength of research lies not only in collecting data, but in interpreting it to build solutions that can shape a better tomorrow. We would begin with the presentations. Also, I would like to inform that every presenter would get 5 minutes for their presentation and 2 minutes for the question and answer session. When science meets sustainability, hope takes a greener shape. Our next speaker, Ms. Manali Tripathi, presents her work in the crucial area of breast cancer therapy.
उसी वाले में जो कॉपी करा था उसमें थी इनकी भी। जो एक साथ और दो आपने एक जगह नहीं कॉपी करी हाँ इसी में क्या नाम है
मनाली मनाली
मनाली तो
हाँ
सही है भाई फोर्थ
Forward, reverse.
First rise. ये second है। Good afternoon, each and everyone who are sitting here. My name is Manali Tripathi, and I'm from ASS department. I'm a PhD scholar doing my PhD under the guidance of Dr. Jaya Pandey, ma'am. Ma'am, my topic is eco-friendly pathways for the design and development of heterocyclic selective estrogen receptor degraders. In short, we say SERDS in a breast cancer therapy. When we're discussing about the breast cancer, first question is arise that what is breast cancer? So breast cancer is the most common type of a cancer diagnosed in the United States. Breast cancer is a disease that causes abnormal cell growth which can spread throughout the body. It can become fatal. Breast cancer cells can start growing inside the milk ducts and lining of a breast. Overviews of SERDS. First one is mechanism. SERD degrades estrogen receptors rather than just blocking them. Current therapeutic options for ER plus breast cancer is a tamoxifen, aromatase, and SERDS. Common type of breast cancer. So basically, there are so many types of breast cancer, but there are a few most important types which are generally found is ductal breast cancer, mixed tumor breast cancer. Third one is a lobular breast cancer, inflammatory breast cancer, etc. what challenges in current breast cancer treatment we face. One is the poor bioavailability and resistance. Second one is a need for effectiveness, targeting, and minimal side effects. So environmental impact, what is environmental impact during the cancer treatment? First one is a traditional drug development processes often involves harmful solvent, chemically waste, and unsustainable materials which are not sustainable or eco-friendly. So the need for eco-friendly approaches in a drug development, sustainable drug discovery. First is the minimizing environmental impact while designing therapeutics. Second one is eco-friendly materials and processes. Green chemistry in a pharmaceutical development principle is the reduce waste, use renewable resources, safer solvent, etc. A role of heterocyclic compounds in a SERD design. What are heterocyclic compounds? So basically, heterocyclic compounds are the organic compounds that includes a ring structure with at least one atom that is not carbon. Common in a drug design due to their uh, versatility. Importance in SERDS, heterocyclic structures can improve receptor binding, specificity, etc. Green synthesis of heterocyclic SERDS, eco-friendly synthetic routes, solvent-free reaction, use of water as solvent and renewable feedstocks, application of catalytic process that minimizing energy use and waste generation. There are two case studies that I have mentioned here. First one is an example of successful eco-friendly synthesis of heterocyclic SERDS. First case study is based on a synthesis of a heterocyclic SERDS via biocatalysis overview, in which biocatalysis as an eco-friendly alternative to transitional synthetic routes, use of enzymes to catalyze a specific reaction, reducing the need for a toxic reagent. And uh, in this case study, the key findings are improved yields with reduced environmental impact. Case study on the specific heterocyclic SERDS example GDC 0810 synthesized via biocatalysis. In second case study, solvent-free reaction for SERD design, its overview, the use of solvent-free reaction to develop SERDS, and key findings are reduced toxic waste. And example of this case study is a specific example where solvent-free synthesis of SERDS resulted in improved environmental sustainability. Next, what materials developed in a SERDS during its process? What materials?
You have simulated these results, or you have physically made these drugs?
Sorry, ma'am?
Simulations, or this is physically made? Results.
Ma'am, so basically it's a computational, not physically.
Okay, computational.
Yeah.
What softwares you have used for this thing?
मैम अभी मैंने इस पे मतलब काम इस तरह स्टार्ट नहीं किया है पर
You are just having some review of
कुछ पीवीबी आईडीज होती हैं प्रोटीन की जिनसे हम एस्ट्रोजन रिसेप्टर को कंबाइन करेंगे और उससे हम पता करेंगे कि कौन से ईआर पे ये परफेक्टली मतलब
How will you do that? That is what I want to know. Whether you have run computer simulations or you have taken material and doing it physically.
very computational and मैम अभी तो इस तरह मुझे सॉफ्टवेयर का नहीं
Beta, when you are doing some review, literature review, you are looking at the things other people have done. You need to find out how it is done. Okay. So software is the first step if you are going to do it on simulation platforms. Okay. Come to your results or anything if you have done.
Yes, ma'am. The summary of a key point is the eco-friendly pathways offer a sustainable approach to SERD design, and heterocyclic compounds are key in enhancing therapeutic outcomes. Some are the future prospects as like a potential for
broader application in other cancer therapies, and collaboration between pharmaceutical companies and environmental organization to create more sustainable therapeutic index. Okay, thank you. Thank you so much.
Thank you, Ms. Malali. The quality of our air defines the quality of our life. Now let's move to the environmental domain with Mr. Pankaj Gautam's research presentation.
Please be in your time limits, Pankaj.
Yeah, I needed it. वो connect वो connect करिए. Yes, Pankaj Gautam. Yes.
जल्दी बैठ जाएगा.
लाइन नहीं चल रहा.
लाइन कहाँ चलेगा? सब बंद हुआ, लाइन नहीं चलेगा.
यहाँ से नेक्स्ट होगा किधर नेक्स्ट होगा? ये नेक्स्ट है, ये रिवर्स. ठीक.
Name is Pankaj Gautam, and I'm first year student of PhD at CSIR IIT Lucknow. And my supervisor is Dr. B.C. Kansar, and also is present there. So basically today, present my topic, changing the effect of source mix on urban and rural area, and load of ambient particulate matter and black carbon aerosols. So when we are talking about particulate matter and black carbon aerosols, so basically black carbon produced thermal burning, and particulate matters are impairs the air quality, reduce the visibility, and cause the air. Am I audible? Sorry for the inconvenience. Also, we find BC at two levels, two wavelength. What, ma'am? With the use of instruments, pulse dust analyzer for the particulate matters, and one ethylometer for the black carbon. We are measuring the black carbon at two wavelength. At the first one is 370 nanometer, and then second one is 880 nanometer. So first did eye sampling the two locations, and after that use these instruments, and meteorological data is also is there. We are correlate. We have seen this correlation of meteorological data and these two sampling locations data. So we can correlate this, and after that, we performed a high split model, high split backward trajectory models, and Windows also Windows diagram also is there. So meteorological data is taken from CPCB, like wind direction, wind speed, and temperature, relative humidity is also there. So we club the data and see the effect of see the effect of how its effect on environment and as well as human health. So sorry, ma'am. So see, ma'am, we have a national ambient air quality standard limits. So these values are higher than this. So you, yes, ma'am. Sorry, I'm not getting that. Higher the high. Yes, ma'am. Yes, ma'am. Two locations. One is urban area Lucknow. The second one is rural area Parisa, which is located in Jhansi. Yes. 15 days sampling durations from 7 a.m. to 7 p.m. 15 days in Lucknow and 15 days in Pariksha. Continuous 12 hours from 7 a.m. to 7 p.m. My result is this, ma'am. This value is higher than our standards and limits. So government can take an action and initiates some green action plans or reduce this fossil fuel emissions. Both the locations, data of both locations is higher, value is higher, and correlation between VC at 880, VC at 370 nanometer is highly correlate and abundant result in shows in Lucknow rather than Pariksha. Thank you. And this one is the two locations. First one is urban area Lucknow, and second one is rural area Pariksha. The value of PM10 and 2.5 is higher in Lucknow, as you see that, above 200, and in Pariksha below 200. And green one is 2.5. This is also higher in Lucknow and lower in Pariksha. And two horizontal lines. The first one is gray. Gray line is about 370 nanometer BC, and the yellow one is 880 nanometer.
You have done some kind of analysis also
Yes,
of this data. Okay, show us the analysis part.
So, ma'am, I performed the high split model here. So high split is basically backward trajectory model, which is shows where air masses comes from here. You can see this in Parisa, there's not that much transboundary effects are there, but in Lucknow is so much there. Resources and long distances, air masses comes from here.
Okay, so what do you conclude from these?
Means lots of rush in Lucknow and lots of hustle and bustle present in Lucknow rather than Parisa, because it's a rural area. There's not that much of rush is there.
Okay, what is the main source of pollution over there then?
Main source like in Lucknow or in Parisa?
Paricha, it is localized somewhere, na?
Yes, ma'am. In Paricha, there is a local cooking activity, biomass burning, parali burning, and cow dung burning is also there.
Okay. Come to the conclusions now.
Yes, ma'am. This one is a Pearson correlation statistical data. We here I have concluded this BC 370 and 880. It correlate between PM and 2.5 is higher than Pariksha, which you can see. So Pearson correlation means, ma'am, which value is nearest to the 0.7 is more. On this topic. Only perform this technique and see the results and give some suggestion to government to take an action to reduce this.
You will move to some other locations also, or the two places only?
Two places.
further study will be in the two places only, right?
Yes, ma'am.
Okay. All the best. Thank you.
Thank you, ma'am.
Thank you, Mr. Pankaj. Quantum science is not the future, it is the present unfolding before us. Our next speaker, Mr. Aditya Singh, will take us into the fascinating world of quantum simulations.
ये वाला मेरा नहीं है ये होगा Good afternoon, everyone. My name is Adit Singh, and I'm here to present my work on computational modeling of quantum materials for qubit realization, a simulation-based approach. So, why do we need quantum computing for this? As we all know that classical computers are becoming very powerful, but they are not reaching a physical limit. Computer chips and microprocessors are shrinking to the size of just few atoms. At this tiny scale, strange quantum effects like quantum tunneling disturb how normal classical transistors work. So, moving forward, we need a new kind of computing on that on that uses the rules of quantum mechanics itself. This is where quantum computing comes in. Quantum materials. To build a quantum computer, we need very special materials. Quantum materials are those whose properties are strongly shaped by quantum mechanics, things that cannot be explained by classical physics. For example, simulating nature. Quantum materials are defined by properties like superconductivity, topological states, strong electron correlations, and
Aditya, come to your work better.
okay, ma'am.
Research objective on.
So wait. So the main goal of my research is to find promising materials for building stable qubits. So basically, we need to preserve the quantum mechanical properties of qubits so we can build strong quantum computers. To find promising materials for building stable qubit, to predict their properties like coherence time, band structure, and noise resistance. And to do that, faster and cheaper use of computer simulation, we need stronger computer simulation instead of only experiments. And the method for simulating to simulate this is we need a blast sphere, and so that for that basically the approach is to design a car before building it. First, we choose candidate materials, then we simulate their performance on a computer, then we simulate then we visualize qubit state using the blast sphere, and finally we predict how stable they are. This way, we can filter out weak materials and push forward the stronger candidates. Here, this is the code I created on Python using Jupyter Notebook. Here, I assign two values of theta and phi. And so this is the corresponding state vector. This is the blast sphere. Here we can see this vector biasing toward zero state. And this is the probability in a graph, histogram form, where we have the 80% possibility of getting zero state and 1% possibility of getting only 14% getting possibility of getting one state. Here the other. Tools and techniques, Python. For this, I used combination of tools, Python libraries like NumPy, SymPy, and numerical modeling, machine learning frameworks like skitlearn and TensorFlow, methods like density function theory and molecular dynamics to study materials at atomic level. These combination of physics, simulation, and machine learning made research both powerful and efficient. Outcomes from this research, I identify the materials that are good candidates for qubits, understanding how their properties affect qubit stability, and building a simplified prediction models to guide future experiments. And overall, reduce the cost and time of discovering new quantum materials. Conclusion. To conclude, computational modeling can speed up the search for materials needed for qubits. Blast will help us understand these states, and combining physics with machine learning can make quantum computing research more efficient and affordable. Future scope. If successful, this work can help in many areas for developing powerful quantum computers, building secure communication system, simulating nature like the interaction of drug molecule and biomolecules. In the future, I plan to apply this method for more materials. Thank you.
See, in this, you have used Python and Jupyter Notebook only.
Yes,
So
ma'am.
these are not optimized tools for simulating your material properties and all.
Yes, yes.
There are specific tools and techniques like RSoft and specialized software which can be used for this.
Yes,
Because
ma'am.
Python is not a suitable platform for
Yes,
this.
ma'am, I know, but this is my capabilities.
No, how will you simulate the properties of material?
For now, only hardware part of quantum computing is developing. There is no work going on in software part. So there are no software present for simulating quantum materials for now. Only they are qubits, they are hardware, but not software yet.
Some softwares are available. You check the website.
Yes, ma'am. Sure.
Thank you, Aditya.
Thank you, ma'am.
Green chemistry is not just a choice, it is a responsibility towards our planet. Our next speaker, Mr. Shashikant Tiwari, sheds light on green chemistry and organochalcogens.
हाँ. Good afternoon, everyone. My name is Shashikant Tiwari. I can pursuing my PhD in MIT School of Applied Sciences under the guidance of Dr. Sangeeta Bajpayee. Today's my topic is green synthetic approaches for organochalcogens. And my main topic of synthesis is tellurium and solarium in group 16. What are organochalcogens? Organochalcogens are a class of organometallic compounds which consist only one metal and one carbon bond. It is a group 16 element, oxygen, sulfur, selenium, tellurium, and polonium, but it is also known as oxygen family. Physical properties of group 16 element: non-metals is oxygen and sulfur, metalloids is selenium and tellurium, and radioactive is polonium. Organotellurium compounds are in this, we have can replace metal from tellurium and join carbon atom. The first organotellurium compound was dimethyl telluride, which are prepared by Waller in 1814. My main focus in microwave and conventional heating. It's my main focus from non-conventional methods. Why I am choosing non-conventional method? Because it is a flow. It is the very low toxicity compared to heating method and conventional methods. In non-conventional method, we are using photochemical, ultrasound, microwave. Green synthesis of organotellurium and selenium compounds. The method is electrochemical synthesis, photochemical synthesis, ultrasound, solvent-free, ionic liquid, and DES. Application of organotellurium and selenium compounds. In this, we have intermediate materials, preferred ligand, catalytic application senses, but my focus is only on biomedical applications. It's my practical work in which we have pH, X, and 2E, microwave. Characterizations. Organoselenium compound. First organoselenium compound was diethyl selenide, which prepared by Login in 1847. Biomedical applications: cancer treatment, drug development, antiviral agent, and antibacterial agent. Conclusion: successfully synthesize a new class of tellurium using optimized organotellurium, unique TEO, tellurium or oxygen linkage. Friends, thank you.
Thank you, Shashi.
Thank you.
Science becomes most powerful when it serves humanity's greatest health needs. Our next speaker, Mr. Ranjan Kushwaha, will present his research on anti-cancer agents.
अमित कुमार मिश्र, क्या नाम है? रंजन कुशवाहा. रंजन कुशवाहा. रंजन कुशवाहा है तो
Good afternoon, everyone. My name is Ranjan Kushwaha. I am a student of ASA department and I am doing a PhD under the guidance of Dr. Monica Kambos. So my research topic name is recent development of macrocyclic metal complex as an anti-cancer agent. So what is a macrocyclic compound? Macrocyclic compound are a unique class of chemical structure a chemical structure characterized by a large ring system containing 9 or more atoms. This cyclic molecule can incorporate heteroatoms such as nitrogen, oxygen, or sulfur into their backbone, giving them diverse structure and functional properties. The rigidity and pre-organized nature of macrocycle often lead to a high stability, selective binding, and remarkable biological activity. They are widely studied in a coordination chemistry, supermolecular chemistry, and a drug design owing to their ability to act as a host for a metal ion and a small molecule. Natural example includes phosphine, chlorophyll, and vitamin B12, while synthetic macrocyclics such as a crown ether and cryptans and calixaran have been extensively developed. So why macrocyclic metal complex act as a anti-cancer agent? Uh, uh, Structure advantages. Macrocyclic ligands form a exceptionally stable, versatile complex with a transition metal enabling a precise tuning of biological activity through a systematic modification of a ligand architecture and metal coordination environment. And the second reason is a selective targeting. They are unique three-dimensional structure facilitate a selective interaction with a specific biomolecular in a cancer cell, effectively distributing cellular growth mechanism and including program cell death pathway. So chemistry and design of macrocyclic complex. Macrocycle as defined by IUPAC, a macrocycle is a cyclic macromolecule or a macromolecular cyclic portion of a molecule. As usually defined in a coordination chemistry, a macrocycle is a cyclic molecule with a 3 or more potential donor atom in a ring of at least 9 atoms. According to this definition, ethylene oxide 1,4-diethane, cyclotetradecane, cyclooctatetrane are not a macrocyclic. These are the example and some biological macrocycle that occur in nature. Heme, the active site in the hemoglobin, the protein in a blood that transport oxygen in a phosphine containing iron. Heme is a prosthetic part of a hemoglobin. And second one is a vitamin B12. It is also a biological macrocyclic metal atom. Vitamin B12 contain a coding ring with a trivalent cobalt atom. It is essential for the normal maturation of erythrocyte for a normal growth and neurological function. Application of a macrocyclic compound. It is used as an anti-cancer agent, antibacterial and anti-malarial, anti-diabetic and antioxidant DNA binding. These are the challenges and future perspective. And it's over. I'm done, ma'am.
What is your work over here, beta? What you have done is only literature review or right now? Presentation, okay. Thank you. Come.
Digital banking is not just about technology, it is about trust and transformation. Our next speaker, Ms. Anukriti Mishra, will take us into the world of digital finance and inclusion. Anukriti Mishra is present? In the meantime, I would like Ms. Anubha Saxena to come and give her presentation on the evaluation of Payments Bank in India, a statistical approach. What's your name, beta? Anubha Saxena. A very good afternoon to everyone present here. My name is Anubha Saxena. I am a research scholar from University of Lucknow under the guidance of Professor Geetika T. Kapoor. So today I am going to present my research paper on the topic Performance Evaluation of Payment Banks in India, a Statistical Approach. To begin with, we have seen a considerable and significant changes in the banking sector of India. RBI decided to, uh, to discover few specialized and differentiated bankings back in 2014, which is small payment banks and payment banks in India. So Nachigate More Committee announced these regulations regarding the payment banks in India. So shall I start from the beginning? Okay. So my topic for the research paper is the performance evaluation of payment banks in India, a statistical approach. So to begin with, we have seen a significant changes in the banking sector in the recent years. RBI emphasized the special and differentiated banks, that is your payment banks, and according to the Nachikate More Committee, a committee on comprehensive financial services for the small businesses and small households. So the payment banks are those financial institutions which bridges the gap between the conventional banking and and the underprivileged areas by giving the small deposits, and the maximum deposits that our customers can have is 2 lakh rupees in such banks. So it provides the various payment bank related services, UPI transactions and remittance. So this paper basically examines the financial performance of these payment banks in the past years. So we have gathered various research papers and articles from the previous studies, and it has basically largely concentrated on the customer perception awareness, and basic tools has been applied for the evaluation of their performance. So very few works have been done on which actually applies the statistical tools like trend analysis and the ratio analysis. So in this paper, we have bridges this gap by applying the various financial ratios and evaluating their performances. So the main objective of my studies is to analyze the financial performance of payment banks using the consolidated balance sheet and P&L statement and various key financial ratios. Second is to identify the trends in the major financial parameters like deposits, capital and reserves, operating profits, etc. And also to assess the current scenario of the payment banks in India. So we have applied descriptive analysis to analyze the financial statements and the financial performance of the payment banks. So we have collected the secondary data from the various RBI reports and the financial statements of the payment banks. So we have done the data analysis by using the trend lines and charts. So we can see that consolidated balance sheet of payment banks from 2019 to 24. So in this, we can see that total capital reserves have increased from the past 2019, from the past 5 years. During the COVID era, it had to face some fluctuation, but after that it has been rising and can be seen the trend, rising trends. Deposits have also been increased by the 8 times from the 2019. Investments have also been shown seen a rising trend from the 2019 to 2024. We can also see that net interest income have shown a rising trend from the past 5 years. Net profit loss, we can see that it was facing, all the payment banks were facing losses before the 2022, but it has now come to the positive aspect that we can see that it has earned 94 crores in 2024. Operating profit, we can also see that it has shown some negative figures in the past years, but now it has seen a positive changes. We have also calculated the financial ratios of payment banks in India. We can also see that the profit margin of payment banks has showed a positive trend in 2023 and 2024. The return on assets and return on equity has shown negative signs in the past previous year, but now from the past 3 years, it has seen a positive impact. So now the current scenario of payment banks in India, basically there are 6 payment banks, but out of 6, one Paytm payment banks has seen some restrictions by RBI, and the most operating and the active payment bank in India is right now is the Indian Post Payment Bank. It has reported 134 crores rupees net profit in the past financial year 2025. And the Airtel payment banks have also shown a net profit which has
Please come
rose.
to your work section. Analysis, if any.
Ma'am, this is the analysis that we have done, and this is the findings. So the findings basically indicates that there are steady and slow improvements in the financial health of the payment banks. We have seen that deposits and investment expanded rapidly, which confirms that the customers are accepting and having trust in these payment banks. Capital reserves and operating margins have strengthened after 2021. The profitability was achieved by multiple banks from 2023 to 2022 to 23 onwards, while IPB, that is your Indian Post Payment Banks, recording the highest net profit in 2024 to 25. So the suggestions for this, that the payment banks, since they cannot lend, so the income capacity is very limited. So I think that the regulatory norms should be changed, and MIREG may consider the limited lending permissions to expand the more income opportunities, and they should work on the cost efficiency as well, which can be improved through AI-based services, automation, and digital KYC. So to conclude with, the payment banks are slowly evolving from loss-making entities to profitable and efficient institutions, but still it has many It has seen many failures in the past years. So for the long-term sustainability and innovation and cost control, the regulatory support will be very much crucial. Thank you.
Okay, thank you. Thank you.
In which year you are of your research? Thank you. You can sit.
I would like to request Dr. Richa Khare ma'am and Dr. Monica ma'am to please felicitate Dr. Nimisha ma'am and Dr. Sumita Mishra ma'am. No, it's not that. Now we are ready. Thank you, everyone. Now continuing with our presentations, every digital transaction is a small step towards sustainable tomorrow. Our next speaker, Ms. Nazia Arif, focuses on UPI and its role in sustainable development. Good afternoon, everyone. I'm Nazia Arif, research scholar in the Department of Commerce, University of Lucknow.
In which
And
year? In which year?
I'm first year. And I'm presenting on the topic, a statistical study of UPI adoption and its contribution to financial behavioral change towards sustainable development in India. Now, since its launch in 2016 by NPCI, UPI has revolutionized digital payments in India. UPI has become a part of our daily lives. It's changed the way India pays. From buying groceries to paying utility bills, everything has now become digital. But what does this mean for our behavior and economic growth? So, most research most of the existing research focuses on the role of UPI in financial inclusion, but its behavioral and developmental impacts are still underexplored. So this is the gap which this study aims to fulfill. Now, the objectives of the study. to study UPI's statistical growth pattern of UPI in India between 2017 and 2024, then to analyze behavioral changes reflected in UPI transaction size, frequency, and merchant adoption, and to assess how UPI contributes to achieving sustainable development. That is how it is linked to the sustainable development goals. Now, the methodology, it is a quantitative study based on secondary data that has been taken from RBI, NPCI, and PMJDY dashboards. And the statistical techniques that have been applied include trend analysis, descriptive statistics, and correlation analysis. Okay. Now, in this, we can see that the number of UPI transactions as well as the value of UPI transactions, there is a steep growth in both of them. Like the number of UPI transactions, they grew from 4.46 million in January 2017 to over 16,730 million in December 2024. And the volume of the value of UPI transactions, it grew from 1,696 crores in January 2017 to over 23 lakh 24,699 in December 2024. So it's showing a steep growth in both the number of transactions that have taken place as well as the value of the UPI transactions. And it represents a compound annual growth rate of approximately 138% for both. Then for the second objective, that is to analyze the behavioral changes reflected in UPI transaction size, frequency, and merchant adoption. So we can see that the trend in UPI per capita usage, that it starts very low, that is less than 0.01 in earlier years, and it rises steadily to 11.3 in later years. So we can interpret that there is a massive growth in digital payment participation, showing behavioral shift from rare use to frequent everyday usage. Then for average ticket size, in early years, it was rupees 3,000 to 4,000 per transaction, but in later years, it declined to around rupees 1,500. So we can interpret that there is a shift from large value occasional transactions to smaller frequent payments. Then, the relationship between UPI average ticket and UPI per capita. So as per capita transactions increase, the average ticket size decreases. So this indicates a behavioral change, that UPI is no longer only for large transfers, but it has become a daily use payment tool. Yeah, also UPI per capita transactions are growing steeply, but the ATM withdrawals per capita has become stagnant. And it also shows a decline. So this shows that there is less reliance on cash now. Then I have calculated a correlation coefficients for GDP to assess the relationship between UPI and the various indicators, that is GDP growth rate, MSME growth rate, POS terminals per capita, and internet penetration rate. So we can conclude that UPI per capita, that is the number of UPI transactions, they have increased from less than 0.01 to more than 11 transactions. So this shows that there is widespread adoption of UPI. Then average ticket size, earlier in the starting, the transaction size was around rupees 4,000, but now it has reduced to around rupees 500. So it shows that from large occasional transactions, we have shifted to small frequent payments, everyday transactions. Then also there is a decline in ATM withdrawals, ATM cash withdrawals. So UPI is not just a payment system, it has driven a behavioral transformation in India's payment ecosystem. And there is a transition from cash heavy to digital micro payments. Then it has also strengthened financial inclusion through active PMJDY usage and wider merchant participation. Then the correlation analysis shows UPI supports economic growth, digital infrastructure, and reduced inequalities. Then, it confirms that UPI is not just a payment tool, but a catalyst for sustainable, inclusive financial development. Thank you.
So how does it relate to SDG 8?
Okay, ma'am, SDG 8 is a decent work and economic growth. So, uh, after calculating the correlation coefficient, it shows that as the UPI usage is increasing, there is also growth in the GDP rate and also in the credit that is available to MSMEs. So it shows that since now MSMEs have more access to credit, since all the transactions can be recorded digitally now, so they have more access to credit.
You are talking about development goals given by United Nations.
Yes, ma'am.
So how is it related to 9 and 10? You have not shown any kind of graph
Ma'am,
or
I have.
correlation. But when you write those things in conclusion, you have to.
Ma'am, I have shown. I have shown the relation.
Okay, show it to me.
Ma'am, here, the correlation of UPI volume with GDP growth rate and MSME credit growth rate. So there is a positive correlation. So this shows that UPI has, whether directly or indirectly, it has contributed to GDP growth rate as well as MSME credit growth rate.
Fine, you should specify it is indirectly leading to that. Because,
Indirectly, yes,
yeah,
ma'am.
because goals
There
are
is a
very specific.
weak positive correlation. Okay, thank you.
अनुकृति है ना, आने दो, टाइम खत्म है हमारा. अनुकृति प्लीज कम.
और कहाँ कॉपी करता हूँ सर आपके पास कुछ पेन ड्राइव है या तो आपने क्या किसको हाँ मेरे पास पेन ड्राइव है
You are also from Commerce Department? Okay. And first year student?
Good afternoon, everyone. Myself, Ankriti Mishra from Department of Commerce, University of Lucknow. It is my privilege to present my paper titled FinTech and Financial Inclusion, a statistical study on digital banking at this international conference. To begin, I would like to introduce two key concepts that form the backbone of my study, FinTech and financial inclusion. FinTech or financial technology refers to the use of technology-driven solutions to deliver financial services in a cheaper, easier, and more accessible way. In India, no, ma'am, it's fine. Sorry. On the other hand, financial inclusion refers to ensuring the access to all financial. Okay. So the basic objectives of my study are to examine the trends in the digital transactions in India, to analyze the relationship between fintech adoption and financial inclusion, where UPI and Pradhan Mantri Jan Dhan Yojana account has been used as indicators, and to highlight the impact of financial inclusion scheme of Pradhan Mantri Jan Dhan Yojana on urban and rural areas. The research methodology used has been descriptive and analytical. Based on secondary data. Secondary data has been collected from various websites like NPCI database, Pradhan Mantri Jan Dhan Yojana database, various research journals. And for data analysis, trend analysis, and descriptive statistics have been used along with correlation. Okay, so first finding of my study shows the growth of UPI and IMPS transactions in India from 2014 to 2025. The orange line denotes the IMPS transactions, which shows a steady growth over the years. And the blue line shows the UPI transaction values, which shows a exponential growth over years. So we can say that people prefer easy, low-cost payment solutions. The next finding of my study shows the relationship between fintech and financial inclusion, which uses Pradhan Mantri Jan Dhan Yojana account ownerships and UPI transaction values as indicators. The blue dots shows the data points of each year with number of accounts or beneficiaries in Pradhan Mantri Jan Dhan Yojana account on the x-axis and UPI transaction values on the y-axis. The trend line shows the direction of the relationship with the coefficient correlation of the relationship is 0.906, and with the p-value less than 0.001, we can say that the results are statistically significant. And overall, we can say that with the increase in the Pradhan Mantri Jan Dhan Yojana accounts, there has been an increase in UPI usage as well. Okay, the third finding of my study compares the rural and urban distribution of Pradhan Mantri Jan Dhan Yojana accounts from 2015 to 2025. The orange bars show the rural accounts opened, and the blue bars show the rural urban accounts opened of Pradhan Mantri Jan Dhan Yojana accounts. The trend line shows the overall total accounts. As we can see, the rural accounts opened have been far more than the urban accounts. By 2025, the rural accounts stand at 38 crores, and whereas the urban accounts stand at 19 crores. So we can say that the financial inclusion scheme brought by the government has showed its impact in the under-reserved and rural area, which it targeted. To conclude, we can say that there has been growth in fintech and financial inclusion in India, which has also helped achieve transparency, curb leakages, and ensure direct welfare delivery. Overall, we can say that with supportive policy measures, consumer literacy, and inclusive design of technology, fintech can be a growth driver and also helpful in furthering financial inclusion for all socioeconomic groups of the nation. Thank you, everyone.
Thank you, Beta. I come. End the session and thank you all presenters. And please come on the stage for the group photograph, all of you, with the coordinators, all.
Apa yang